they took my feedback. They recorded a video that they will
Okay,
send to
okay.
IIT Madras. But it was really very stressful. It took me some
Yeah,
good
I get
15
it. Yeah.
minutes to settle down because the student right next to me, he had a runny nose and he would take off his
Yeah, yeah,
mask and wipe his nose. So you can
yeah, 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 I
understand
get it.
the
Yeah, yeah.
kind of stress I had to go through. I even contemplated, if I should leave.
Yeah, I can
So
understand.
yeah, but yeah, I found it difficult to
Yeah.
because I
Mm.
lost a few minutes in the beginning.
Mm-hmm.
I struggled. I was racing
Yeah.
against time to complete my
Yeah.
paper.
Like this problem, it's actually arise because so many students wanted to change the center at the end. So, I think they wanted to accommodate more students to the
Mhm.
particular center, so they would have done it. But in any case, this is not right. I totally understand this because it's
Yes,
a
and
foreign
especially
time.
with
Yeah.
the new this in this wave. I mean,
Yeah,
uh,
yeah, I get it. Yeah.
it's spreading very fast. So I was, I mean,
Correct. Correct.
I did not even, I was feeling very thirsty, but I did not remove my mask to even have
Mm-hmm.
water. I
Mm-hmm.
waited till I left the examination hall. Thankfully, it was only 2 hours for me, not 4 hours. I mean,
Okay.
the other kids must have really struggled then.
Mm-hmm. Maybe I'll personally tell this to our team that this thing has happened. And actually, we should pay attention to this part seriously, right? I mean, we had been experiencing from past 2 years like all these. So
Right.
definitely we'll do this something.
Thank you, sir.
Sir,
Yeah. Yeah, yeah, Rahul.
sir, in my center, we had a 20-minute outage due to technical issues. We were not given any extra time for those 20 minutes, sir. So,
Oh, I see.
yeah, in Hyderabad. So,
Oh,
is there going to be any compensation like?
I don't think so any compensation, but there is something else which is being planned. Like I don't know, like I should tell it right now or not, but something will tell you, will announce you soon.
Okay.
If some, yeah. Okay.
Means
Anyhow,
was
so
it is related to means examination or anything else?
this session.
No, means you said
Okay.
no something is being planned. That's why I'm asking. Means is it related to examination or
Related to
anything
examinations. Yeah.
related to examination?
Yeah. So yeah, that is the thing. So do you
Means it's
guys want to?
beneficial. It's
Yeah,
beneficial
yeah,
for us
it's beneficial to
or
you.
just a headache for us.
It's beneficial. Don't worry.
Thanks. That will be a
Yeah,
lot of.
yeah. So do you guys want to discuss anything more, or should we just start with our week 5?
Start,
I
sir.
think we should start, sir. The
Yes, sir.
deadline
Should
is
start?
very
We
near.
can start. I
Okay.
guess.
Okay. All right. So let's start with this. So just a minute.
Hello, sir. Can you tell me whose day week 5 deadline?
Week 5,
16, I think.
6, is
It,
it?
it's on 2nd, right? 2nd of January, the day after tomorrow.
January. Okay.
Yeah.
Okay, sir.
Still
Thanks,
have
sir.
less time. Yeah, but don't worry. This week is like not very lengthy week or something. It's like easy doable. Okay.
Yes, sir. That is,
Yeah.
but
Yeah, but still, I
And
understand.
even next week we also easy, sir. I think.
The logarithm.
Yes, sir. It was also.
It depends person to person. Like you go through contents and see if it is really easy. I feel like most of the student complaining about logarithm thing because there is a strong intermixing of week 5 and 6, right? So
Yes.
that is
Okay.
something you will see. So in 6 you will see the application of week 5 or something. It's like that. So
Because
you have some.
it's logarithmic, it will be involved everywhere. I think
Sorry.
it's logarithmic.
Yeah,
matlab,
logarithmic function is
general
something.
function.
Yeah.
Yes, it will be involved every year.
Hmm.
So, sir, should I know some of the logarithm or means you will teach from the basic?
They will teach you from the basic only in the videos, so that is okay. I mean, I don't think for any course you need to really go through somewhere, but wherever you feel like you need some supplement, you can always see some videos or like some contents from elsewhere and build up
Okay.
your foundation. So that
Okay.
always you can do. Yeah, but for logarithm, like I think like I would personally suggest, like
Hmm.
if you pay attention to live sessions, no,
Hmm.
live sessions, that will be really helpful. I mean, I personally see it's not a compulsion that you should attend a live session, but I feel like there is somewhere you need some assistance
Hmm.
from us so
It's
that
really helpful, sir. It's really helpful, sir. Live sessions.
Yeah, it's very helpful. Basically, that relation question I would have done wrong, but it was right because of the live session. That last revision
And
Yeah.
session was very,
SHC, sir, also word problem also, sir.
yeah.
Okay,
These
good.
are the something which are
I was expecting a little tougher question, but it was kind
Yeah,
of.
yeah. Even we felt like, did we really make it too easy or something? But
Yeah.
later on, we thought like it's okay. Let's see. We experimented this. How many of you will pass? We'll see that. Actually, not much passes. Even if we see, if you see in the live session, I literally discuss the questions.
yes, sir.
Yeah.
Yes.
I literally
That's why.
discuss the questions.
That's why they are easy, sir. That's why they are easy. It's a
If you can.
level is not
People who don't
easy.
attend, they feel it hard.
Yes, sir.
So you would have seen it. Even that question, that particular question, involving set theory. Exactly the same numbers are there. It's just the context I have changed. And instead of 1000 or 2000, I have given 5000 as a value. I was hesitating a lot, for giving that particular question. I was like, should I give it? But we just wanted to experiment. Like, even if you provide materials to the students, how do they perform? Like, we just wanted to see this. So this was an experiment. So let's see how many of.
Please do this every time.
Sorry, do that.
Please do this every
Is.
So, but the sets theory question was also very easy compared to last
Exactly.
qualifier,
Mhm.
and the weightage was also more. I think last time it was only 6 marks. Here, I think it was more than 6. I think around
9
9
marks.
marks.
Yeah,
Yeah.
9 marks. Yeah, that is too much.
Excuse
Yeah.
me.
Go ahead.
I have a doubt. It clicked just now. The question on sets, did it ask for percentages or number of students?
Number of students.
Oh God.
Not
Yeah.
percentages, bro.
I
No,
repeatedly
and sir
told in the
mentioned it in
Sir said
the
at the
while
last
during the
session.
revision lecture that he's mentioning, but still he was
Yeah.
very confident with his
Very
experience that
clearly.
students do make mistake in
He's just
not
one,
giving
but
the
you see, there
numbers.
will be like hundreds of you who
No,
will
no.
be
All the three questions or just one of them?
all of them.
All of
Oh,
them were
I,
on
you
that.
really.
All
I
of them.
messed up 9 marks then.
I see. You attended the previous live session?
Yeah, I did attend, but in the exam hurry, I
Yeah,
messed
yeah.
up.
I know. Like that's why I was cautioning you guys.
Yeah, one more thing. The week 5 deadline is on 6th, right? Somebody was saying it's on 2nd of February.
Okay, like, we can just check it right now.
It's 6 Feb, sir. 6 Feb.
Sir,
Week
week
it's on
5
6th,
is
sir.
6, but week 6 is on 9.
Yes.
Week-
Yeah.
Week 6 is 9, yes, sir.
Okay.
There is 2 or
Week
3
five.
days just between them.
Mhm. So don't worry. Like those who are thinking, why didn't I start the session yet? I just kept like 15 minutes to discuss with you guys, like, okay, what is what not, right? So don't worry about it. In another like a minute, I'll start. So you were asking like week 5 deadline, right? So I'm on the portal.
So it's on 6th of February.
6th, right? Yeah.
I think everyone is getting
Yeah. 6th.
confused because of the format.
Yeah,
date
it got
format.
changed, right? Yes.
Sir, but week 6 is on 9th, sir.
Yes, sir.
Yes, it
Oh,
is
I
on
see. They saw this. Okay. DDMM format. Okay, right.
Mhm.
Yeah, I was sure before, but somebody said it is on 2nd, so that's why I just wanted to confirm.
So I would tell you, like, you just finish your week 5 as soon as possible. I mean, try to finish it very early, okay, and then concentrate on your week 6, because week 6 you have some concept which you first have to solve. You first have to know the properties of logarithm. Then you also have to know the graphings of the polynomial. Also, you have to solve certain problems, word problems. Then you also have intermixing of week 5 and 6. So you have so many things which is happening in week 6, right? And you have less time, so you should actually you should start doing on that, okay? Because you see, week 5 exponential, and when you want to solve a logarithmic question, you actually reduce yourself to an exponential, or sorry, if you want to solve an exponential question, you actually take log and solve it, right? So you will see that application thing is coming up there. So that's how that becomes a bit tedious. I mean, it's not very, but you need some time. Okay, so let's start with our session today. So I mean, since you would have not gone through what is there, I mean, if you have not gone through the contents of week 5, so I'll just tell you summarize the things, so that when you go and see the videos, it will be helpful. So basically, like, let's start with our exponential function. So here it says now exponential function is generally written like this: f of x is equals to a to the power of x. Okay, then what about a? What all a can be? So a is greater than 0, and you see, notice this, and a is not equals to 1, and x can be anywhere. Clear? So I hope I'm clear on this. So this form of representation forms an exponential functions. That's all. Okay, nothing much. So what else now? What else we can do now? What if you have some important, like some important things that you should keep it in your mind while you're solving exponential problems? So what are those things? Like if a to the power of 0 is nothing but 1. So it's basically anything to the power of 0 is 1, right? What about e to the power of infinity? It is infinity. What about e to the power of minus infinity? Naturally, it should be 0. So keep these three things in your mind while solving your problems. This thing, and this thing.
Sir, why last one is 0?
What is 1 by infinity?
Okay.
Right. So now we got this, right? So we got some understanding of exponential functions. So now whenever we do a function, you always keep a practice of this. Whenever you have a function, you try to visualize it, right? You just try to think like, okay, how will this functions look like graphically, right? So it's always graph, right? So now how does this look like? Okay, so now if I have to draw this, so now here you can see I can partition this a into two parts. Right? So when a is greater than, so maybe I can just draw this here. I can just make a function f of x is equals to a to the power of x. Just give me a minute. Okay, now I can scroll. So now let's just understand this. So this is my function f of x is equals to a to the power of x. And you see your a is suppose in between. So I'm partitioning this a. I'm just dividing this a, since I was telling a is greater than 0. If I have to just keep a number line here, 0 is not included and infinity is not included, right? So in between, and you see there is some interval a is not equals to 1. So this is some here. So I'm taking this as one interval and I'm taking this as another interval. Okay. So I'm just partitioning this condition. So basically I'm exploiting this given condition and I'm trying to see how does this function look like, right? So now if I have to look this, so this is one partition which I can take and another is a is greater than 1. So I have exploited these two conditions, right? And I have also made sure that a is not equals to 1, right? In both the cases. So now let's look at how does the things varies here, right? So first let's look at the graph itself. So first parameter which I'm taking is graph. Okay. So how will the graph look like when your a is in between 0 and 1? Okay. So 0 and 1 means you can just keep one example. If I'm just giving an example, if a is half, right? So this is one case. So now I'll just try to draw the graph for this. So this is just an example. Okay. So now you see how does the graph look like for this. So you just have to memorize this as if now just keep it like the graph is like this, like how we used to do for x square, it is parabola, and how x cube. So it was crossing from 0 and you know the nature of it, right? So that is something, as you were keeping some graphs in your mind, just the same way, understand that this is also something like this, that you have to keep it in your mind and later on we can build the complexities on this. Okay, so first understand this. So now how will the graph look like for this one, right? So always, okay, just a minute. So this is the graph for this. This is the graph for f of x equals to, I will just write it down, half to the power of x. Clear? So this is fulfilling this condition, right? So you can also say this is general graph for f of x equals to a to the power of x when this condition is there. Okay, and this is the nature of that graph. This is the characteristics of this graph. Okay, and always at this point, could you tell me what will be the value of your y-intercept at this point? If this is your 0 and this is your x-axis and this is your y-axis, Could you tell me what is this y-intercept? Anybody?
0.5,
1.
0.5.
So it is going to be
One.
it is going to be 0 comma 1. How? Just put this value, just give it 0 here. X, when x is 0, what do you get your f of x?
1.
I just told you here, a to the power of 0 is nothing but 1. Anything to the power of 0 is 1. So I am very much clear with this, right? Now what about the graph for this one? When a is greater than 0, so you see that the graph naturally goes something like this. So again, this goes something like this. Okay, so now this is your f of x. So maybe I can give an example. Here a is equals to 2, which is fulfilling this condition. So here f of x is nothing but 2 to the power of x. So you see, you take any values here, you will always find your y-intercept to be the same. Now tell me what will be the y-intercept for this? Again, 0 comma 1.
0, 1.
So basically, yeah, so this is something, and this is my x-axis, this is my y-axis, right? So now
sir, A is half and A is 2 for both the cases.
a is half and a is 2 for both the cases. I didn't get like what you're trying to say.
So there are two split, right? A less than 0 and less than 1, and A greater than 1. For
Yeah,
A less than, so A is there, right? A to the power x.
So you take any values in between here, you will see the characteristics of the graph is something like this. Okay. Okay. So now we understood the graph. So just keep it in your mind. If you have something conditions like this, this is how the graph is going to look like. Okay. Now we'll take up the other parameters to understand this. Okay. So now graph is done. Could you tell me what is the range of this function? Tell me what is the range of this function. Just look at the graph. Just tell me what is the range of this
0 to
function.
infinity.
0 to infinity, sir.
1 to infinity excluding 1.
0 to
Infinity.
infinity is 0 included?
No, sir.
No, sir.
Okay. What about this? What about the range for this? 0 to infinity is 0 included?
No, sir.
No, sir.
Okay, so now we understood this. So you see, the life becomes very easy when we have graph in our front, right? Right. So if you make the graph of anything, you can actually do anything. I mean, you can exploit exploit the function's properties in all possible ways, right? So now this is one thing, right? What about the domain for this?
Sir, all real x.
All real.
How do you understand that? So you see, you can take all values of x, right? There is no point of discontinuity. You can take all the values of x. So can I tell this is R?
Yes, sir.
But here also, can I say this is R? Because see, there is no breakage. It's continuous in all the values of x, right? So the domain is R. Clear?
Yes, sir.
I hope no doubt till now. Now let's go to the next.
So can you explain the range again?
Yeah, I'll come to this. Range is that all set of possible y values it can take. Could you tell me what is the possible y values this function is taking?
Okay.
Right?
From 0 to infinity.
Right?
Okay.
We are here as well. 0 to
Yes,
infinity. And look at this part. What do you mean by domain? Set of all possible x values that your function can take, right?
Domain I understood, sir. Thank you, sir.
Yeah. So what about x-intercept?
Sir, 0, sir.
Is there any x-intercept?
No, sir. I don't think.
No, sir. There isn't any.
There is no x-intercept here. What about y-intercept?
1, sir.
0, 1.
You can tell me in form of points. So it is going to be 0, 1, 0, 1. Okay. What about asymptote? Now we are learning something new. So let's just.
Sir, 1 asymptote.
One asymptote, that is fine. But could you tell me what is asymptote? Let's discuss this and then we'll come to this part here. So I'll just drag this here and then we'll come to asymptote. So what do you mean by asymptote?
Sir, something who is like
The value coming closer to any one of the axes.
Okay, I will just tell you one statement. Just we'll stick on to that statement. Okay, you can make some modification to it if required, but just stick on to these statements. So asymptote is nothing. Asymptote of a curve is a line. Okay, so what do you mean by asymptote? It's basically, so I'll just write down here, asymptote of a curve is a line such that, okay, it's basically a line. So you have to give emphasis to this. Okay. Asymptote is a line. Okay. Such that the distance between the line and the curve approaches 0. Okay. I hope I'm clear, right? So now just tell me before going to that graph. So now I'll just tell asymptote of a curve is basically a line such that the distance between the line and the curve approaches 0. Okay. Now if I have something like coordinate plane, something like this, okay. Could you tell me what is the equation of this line? Just a minute before giving any answer, just if this is y equals to 1. Could you tell me what is the equation of this line?
Y equals to 1.
Y equals to 1. Could you tell me what is the equation of this line?
Y equal to
Y equals to 0.
Y equal to 0.
Y equals to 0.
Y equal to 0.
Okay. So how do you understand this? So basically, you give any value of x, no matter you give any value of x, your y is fixed. Right?
Yes.
Over here also, no matter what x value you give, your y is fixed. That's how you're getting. Similarly, could you tell me what is the graph or the what is the equation of this?
X equal to 1.
X equal to
Okay, this is 5.
X equal to 5.
X equals to 5.
Okay, so this is x equals to 5. Similarly, if I have to draw it here, then you will say x equals to 0. Now this is clear to us, right? So basically, this is equation of a line only, right? This is also equation of line. This is, you can say, equation of line. So, right? So this is something we understood. Now let's understand this. Now let's say if I have a curve, okay, now I'll erase all these or just let it, maybe I can erase this. Now look at this part. Now let's say I have a curve, which is something like this. At 1, it goes to infinity. Let's say this is something like this. And you get something like this. Okay. So now if I have to say this is some function, let's say f of x. Okay. Now I'm finding asymptote of this function, right? So asymptote of a curve is basically a line such that the distance between the line and the curve approaches 0. So now you see that this keeps on increasing. As x increases, there is no concept of asymptote coming in. But look at this part. But look at this part, right? This is something approaching somewhere, right? And where is it approaching? Let's say this was 1. So now if I have to draw a line, something like this, right?
Yes, sir.
So you see that the distance between these two lines, this is what it's saying, no? Asymptote is a line such that the distance between the line and the curve approaches 0. What is happening? The distance between these two lines, is it approaching 0?
Yes, sir.
So can I say this line is an asymptote for this curve f of x?
Yes, sir.
Yes.
No, sir. It touches like it.
Baba, it doesn't
intersects.
touches. It doesn't touches.
Doesn't
It's just
touch.
that I can't draw that. So just understand. Yeah, I mean, typically you can say, okay, maybe I can, I can do this, but how will I go further more? But
If it touches, will it become tangent?
then you can say that.
It's never touches.
Only
na?
we discuss about the
It
distance.
Never touches. It says no. It approaches 0.
Yes,
right?
sir.
So you see the distance is approaching to 0. So can I say this line as an asymptote? Because the asymptote definition is that only, right? It's basically a line.
But if it won't touch, how distance will become 0? Some distance will be there. na, if
approaches
it won't
0.
touch.
Approaches 0.
It will
Approaches 0 only, na?
It
Not exactly 0.
approaches 0. Yeah, it never reaches 0. Just approaches.
Okay.
Hmm.
Okay.
So now
So
can
it's
I
kind of like limit, right?
Yeah, it's kind of
It
limited.
goes near and near to 0, but it's not 0.
Never 0. So could you tell me what is the asymptote of this line here?
X equal
Sir, x equal to 1.
to 1.
Wrong.
Asymptote.
Oh, sorry. Yes. This is 1. No? So x equals to 1. Yes. So what is the asymptote of this curve f of x? X equals to 1.
X equal to 1.
Likewise, yes. Any doubt? Tell me.
Sir,
Yes,
sir, can't we draw a horizontal line, sir?
That's what I was telling. You will never approach 0. You see what I mean, see, this function is strictly increasing, right? It keeps on increasing as the x increases. So
Yes,
no
sir.
matter wherever you draw that horizontal line, it will intersect that line.
Okay, sir.
Okay, sir. Sir,
Right?
so in only this curve it is having one asymptote, because
Yes,
in some
exactly.
curves we can have two
Multiple
asymptotes.
asymptotes. Yeah, you can have multiple asymptotes. That is perfectly right. Okay.
Okay, sir.
You will have log, let log come in. You will have multiple asymptotes.
Sir, I have one question.
Yes.
Sir, there was a previous question. If the line the asymptote x equals to 1 touches the curve fx, it would be a tangent.
Hmm.
Sir,
If it
but
just touches, yeah.
if it is touching, don't you think it will be touching multiple times?
But see, tangent is a concept of local properties.
Yes, sir.
It's a concept of local properties, right? Let's
Yes,
say
sir.
you have a sine function. Let me not go here, but since you raised it,
Yes, sir.
right? Can I have the, can I say this since this is one? And can I say this as a tangent? So to others, do not get confused. This is just an outside topic, just to tell him, okay? We'll come
Sir,
back
I
here.
don't think it will be a tangent because it's starting at 2 points.
No, no, no. It is a tangent because the definition of the tangent is, you have to stick on to the definition again. A tangent is a line which touches the curve, right? In that local, there is something called, it's basically a local property. So you take a very small interval, and in that interval, you check whether it touches that point or not. You
Okay,
doesn't
so
take the
So we
entire
are
value.
applying limit.
so we are focusing on dy dx, a small part.
Small part, yes.
Okay.
You're not doing the entire thing. So
Okay,
a
sir. Thank you.
tangent is a concept, it's a local property. It's a concept of local property. So you doesn't take the entire thing there. That's how, so when you find the tangent in this local domain, restricted domain, is it touching at once? So yes. So this is the thing. Okay, so
So,
we'll
sir,
discuss
when we
this
are
more.
finding a local property, we'll ignore the whole.
Yeah,
and
you ignore
just
the whole.
Okay.
This thing we'll discuss more on week 7, 8, and 9. So we will start the concept with tangent. We'll go to 8, and then this concept of tangent will get cleared here. Okay, so you will start with this, but I think we'll discuss more here itself in week 7 or week 8. The
Yes,
concept
it
of tangent will be clear.
calculus part, sir.
Okay, sir.
We can deal that more in the calculus part. Okay, so let's
Yes.
just stick on to week 5 and 6, because whenever you study, you take this as one modulus, right? So you take this as one module of studying, week 5 and 6 together, week 7, 8, 9 together, and week 10 and 11 together, because this is how you have to go through. Okay, so now let's come back to our topic. We were discussing asymptote to everyone. So now come to this part. Could you tell me what is the asymptote for this?
Sir, one y is equal to,
This is something like this.
yes.
Y is equal to some constant.
Y is
X is equal to 0.
Y is equal to 0.
Yeah.
Over here as well, could you tell me what is the asymptote? Y is equal to
Y equals to 0.
So now we are convinced, like, yeah, this is the asymptote. So I'll mute all of you, like those who want to speak can unmute and speak. Yeah. So now we have this asymptote concept is clear, right? So now let's go to the next part. Now next part says, what about the nature of this, right? Whether it is increasing, decreasing. What is nature of this function? Is it increasing or decreasing?
Decreasing, sir.
Decreasing.
Yes, sir.
So I can say it is decreasing. What about this one?
Increasing.
Increasing, right? So you see that this function is decreasing and this function is increasing, right? So you see, you have to respect this, whatever this condition is given. When in this condition, this exponential function is strictly decreasing. And here, in this particular condition, when a is greater than 1, you see that function is strictly increasing. Clear?
Yes, sir.
Sir, can you repeat, please?
Yeah.
Since there was issue.
How will the graph behavior changes if a increases the value of a in a power x?
This will become more steeper. When let's say a is 100.
Yes,
So
sir.
if I have to draw the graph, let's say 2 to the power of x, and let's say 1000 to the power of x.
Yes, sir.
So the graph for a to the power of x is, let's say, something like this. The graph for this one will become more and more steeper. So you see, how do you understand this? When you give x equals to 1, so if your x is 1, what do you get?
1000, sir.
So you get 1000 here, but what do you get here? 2. That means this is something like this, but look at this part. When this is the case, this will be something like this. Maybe
More and more.
it will appear as if this itself is asymptotic in this part, right? So this is something going to be like this. So this is the graph for this one.
Understood, sir. Yes. Thank you,
Okay.
sir.
Yeah. So all right. So now we understood the nature also, right? So somebody asked me to repeat this. So you see that as how do you check the nature of the function? You come from left to right. As you are coming from left to right, is your f of x increasing or decreasing? Decreasing.
Decreasing,
Right?
sir.
That is why this thing has come. What is the nature of this function? Decreasing type. As you go from minus infinity to positive infinity, what happens to your f of x? Increases.
So they're increasing.
So it is increasing. Clear? So now we understood the nature as well. Now what about the end behaviors? Right? So just this is basically not required, but just we need one more parameter to discuss. So let's discuss end behavior. Okay, what happens when your x tends to infinity here? When x tends to, let's say, minus infinity, what happens to your f of x?
Infinity, sir.
F of x goes to
Infinity.
0.
Zero, zero.
Or like you can say it tends to 0.
Tends
Right?
to infinity, then only your f of
Sorry,
x
sorry,
is-
sorry, sorry. Just a minute.
Sir, infinity.
Should be infinity. I understand.
Infinity.
As you are
Yeah.
going, when x goes to minus infinity, so when you are going very far here, what happens to this function f of x? It goes to infinity.
Infinity.
Thanks for pointing this. So when x goes to positive infinity, what happens here?
It's a
What
process.
happens to, just reverse the process, right?
It's a
So when
process.
x goes to infinity, what happens to your f of x? Approaches
Zero. Approaches zero.
Zero.
approaches 0. What about this?
It's reverse the condition.
Just reverse. I'll just simply just reverse the condition. So when x tends to minus infinity,
f of x
F
equal
of
to
x
0.
hmm,
X tends to infinite. F
Sir,
of x is equal.
equal to 0, na sir? Approach to 0 always.
sorry,
Sir, f of x equal to 0.
no, you cannot
Hmm.
say f of x equals to 0, right?
So it's a
Approaches
process.
zero.
Yeah, okay,
So you
here,
have to
here,
check
here,
back.
here.
That's
Mhm.
the answer.
Sorry, yeah, thanks.
Yeah.
Okay, so now we understood this. Clear? So now we understood this. Now these are some basic properties. Now if
Is
I have
this
to switch,
symbol to say approach? Arrow mark?
yeah, tends to or approach. This symbol says implies. This symbol says implies. This says tends to or approach. You can say that. Yeah. All right. So now,
Approximately is different, na symbol?
approximately symbol is different. So now we understood something like this. Like this is something happening, right? So now we understood now we have some broad idea about the exponential functions. Now let's take up another example, something called natural exponential function. So what do you mean by that? So maybe I can zoom this further.
Exponent is natural number?
Natural natural number, no, not natural number, that is different. So natural exponential function. Okay, so this is so let's just discuss this very small topic. You can just tell everything. So now how is this represented? F of x is equals to e to the power of x, and the value of e is something. Can someone tell me some value? 2.7 blah blah blah, is it?
Yes, yes, sir.
Something like this only, no? The value of e?
Yes, sir.
2.71828 and so on.
7 1 something, right? So now you see this is special condition. Now can you tell me where does this function fits in? Whether it fits in here in our first column or here or here? Where does this function fit in?
Second, a greater
Second
than
one.
1.
The second
So the
one.
entire property is the same. The rest all entire property is same. Clear?
Yes, sir.
Okay.
Sir, E is an irrational number, right?
E is an irrational number, yes.
Yes.
Okay.
So clear?
Yes, sir.
So now you see that this is basically E is a special case which fits in this part. That's all. Rest all properties will be same. Clear? Another some properties which you will see is now what happens to its area under the curve and all that things. I would appreciate this if you can do this much more in maths too. But just to tell you some properties of this, how does this function look like? So if you just draw the graph for this exponential function, this is how it will look, right? E to the
Yes.
power of x, and the y-intercept will be
Yes.
0, 1, right?
Yes.
So when you take what will happen when x is 1? What happened when
So-
x is 1?
E equals the value of fx will be 2.7, the value of
So
E.
basically
718.
E, right? Basically E. So what is being told is, now this is very important property. When you take this area under this will actually give you E.
Wow, it's great.
Yeah. So area under when x belongs to, let's say, minus infinity to 1, the area is, so when x belongs to the area is E.
We will integrate it to the limit
Yeah.
0 to
Yeah.
minus
Could you
infinity.
tell me, if somebody is very much like, if you know something more about this, could you tell me what is the slope of this function at 1? Slope at this point.
Sir, e to power x.
E to the power x, sir.
No. At x equals 1, just tell me the value. What will be the value? E to the power of x is general slope you are telling. At this point,
1.
yes.
sir?
No, not 1. E, yes. That's the right answer.
E, sir.
To all those who are thinking, okay, how did he found the slope for this?
0.
No. Slope is E.
E.
Okay.
Slope is E at x equals to 1.
So e to the power 1 is E.
So just substitute x equals to 1, you get that slope. So you must be wondering, okay, how did we get this slope? Don't worry, we'll discuss this again.
I
When we are
think
in
it's
week
P
5,
by
6, 7.
ds e to the
Sorry,
power
7,
x.
8.
So we
when you
generally differentiate and substitute one, right?
Right, yeah, that's what. No, so when you take f of x is equals to e to the power of x, derivative of e to the power of x is nothing but e to the power of x. And when
Yeah.
you substitute 1, so what do you get? E, that's all.
E.
Yeah.
That's how. So now we understood some properties of this. This is more than enough for this part. We are
Excuse
done
me?
with this. Yes.
As an aside, this is not related to this, but what is the significance of E? I mean, why did we choose only E as E is equal to 2.7 is an irrational number, right? What is the significance of E in mathematics or in practical applications as such?
So you see, there are certain things which we actually learn from the nature, right? So now let's say if you are to ask me what is the importance of Fibonacci series, right?
Fibonacci, yes.
Yeah. So how do you see that? You see in the nature, even you see the arrangement of your petals, like everywhere.
Yes.
It goes in that order. So now if you are to ask me, okay, why is it important in mathematics? So basically mathematics is a language which you apply where? In physical world, right?
Yes.
So how does something get importance in mathematics when something finds its applications in natural world? Right?
Yes,
Or in
I was
physical world?
exactly interested in that. Where does
Yeah.
this find applications?
No problem. So that's what I was coming to this. So Fibonacci series, why, if you were to ask me at that point of time, where is its importance? Its importance is in the real world, right? That's how this E concepts will have its applications in the real world. Let's say in the stock market, or like, let's say something, if you want to predict something model somewhere, this E becomes very handy there.
Okay.
We can use it as a metric also, I guess.
You can use it in there as well. So you have so many concepts, so many places where you will find these applications of E. So that is how this is just, one example, one analogous example I gave.
Actually, what means E? What it is?
E is
Natural
some
logarithm,
value.
I guess.
E is some value. E is
It is an
Now, what it means?
irrational
What
value.
it means actually?
What it means?
Pi we know. Pi is what is pi?
What does,
That is
okay, so
we know,
you
like
mean to
what
say
it
like
is.
pi concept has come from, somewhere from circle.
Yes,
Okay.
yes. So
E-
how this E?
Okay. Maybe actually I don't know how. As of now I really don't know like how.
Okay,
how
let's Google. No issues.
yeah, that's right.
Exactly, that was my point
Okay,
of
so you
asking the
asked that
question.
thing, is it?
No,
Okay.
I mean to say, what is its significance in a way? Where are we going to find its
Right.
supply? Otherwise, it would be meaningless. We would differentiate, integrate, whatever, but
I
we
get it.
wouldn't
I
know.
get it. No, it's good. It's a good question.
Yes.
Maybe you can
find
Google
it
as
in
if now.
mountains also. Means if you just see a steep mountain,
You can do one thing. You can take this, as a task, actually find its application and how did it came through. Post it in a forum, right? Like forum in the sense like you have that Google forum or like.
Yes.
Actually, we don't get these questions while studying in college, but now get it.
Yes, sir.
No, it's good. It's good you're getting this. Okay, anyhow, so let's go ahead with our topics right now.
Excuse me, sir.
Yes.
Can you please go back to the graph you made while explaining asymptote? So, like along x-axis, this graph will go till infinity.
Along x-axis.
Yes, sir.
Yeah.
So, sir,
Yeah.
cannot this graph be viewed as like the distance is also increasing if we look at it from y-axis point of view? Along x-axis, the distance is also increasing.
No,
So
that's what I was telling you. Like you have to see your perspective here, right? So now this is something you can actually,
this
you know,
can
you can come
be viewed in both ways, that the
both ways,
distance is
right?
decreasing also and it is increasing
Right.
also.
Right. But you know, like you always see what are we telling? The curve approaches zero, right? The distance between the line and the curve approaches zero. So now again, like that is your perspective. Now, if you're thinking, now if you want to think it in this way, when y is increasing, then how is this curve? Now, what is the distance between them? It is certainly increasing,
Yes.
right? So you want to find the solution for this, or you want to divert from this, right? So that comes in here. Like if you want to find the solution, like if you want to find the asymptote, why will you find the diversity there, right? You will look for whether it approaches to that thing or not. If it approaches, like what is the condition, right? Certainly you can do that. Like you can think it in this way, but why do you want to do it in that way, right? That's the question.
Okay. Thank you, sir.
Yeah. So clear. So I think this is okay. Now, one question was like, what is application for E, right? So E, that is something, let's take it as a homework and do it, right? And put it in the forum for others as well. Maybe even I can see that.
Sir, one question.
Yeah.
Do exponential functions always have horizontal asymptotes only?
Yes. Like for this particular condition, yes. And it need not be always this thing. Now, if I have to ask you a question, something like this, e to the power of x plus 1. How will the graph look like for this?
This will go up by 10 units.
So
10
this,
means just it will be in
So y equal to 10 will be the asymptote in this case.
no, it will be 11.
Okay.
e to
Right?
the power 1.
But what asymptote? What will be the asymptote for this?
Y equal to 11.
Y equals to 10 or 11?
10, sir.
Less than 11.
Yeah, less than 11. So that is 10. Clear?
Okay.
Yes, sir.
Okay. So now this is done. This is done. Now two things we have done. Now we understood what is exponential function. We also understood what is natural exponential functions. Okay. Now let's look at some important properties, which you will see it in your these things. There is also concept of composition of function. I hope we have more time, right? Yeah, we have more time.
You mean
So
that f of x is g of x, that one?
So it's very important, sir. I think.
Yeah, very
Composition
important.
of functions, yes. So now let's discuss that. And there is something also concept of this one, wherein, you know, in your videos, you would have seen something like, what do you mean by vertical line test and horizontal line test? I think sir has explained it very beautifully. You can just watch that. Maybe I'll not discuss that.
Yeah, it's clear in the video. It's
Yeah,
clear.
it's very clear. So you just see that video. It's very simple. And I think even I have also discussed what is horizontal line test. Vertical line test, you can see the same thing, right?
We
It's
can
simple only.
one function also.
I'm pretty sure you will understand that. So I will not give more emphasis to that one. So what I'll give emphasis to here is like where you tend to make mistake, right? So
Drawing the square root functions also little bit difficult.
Square root functions, yes, I understand that. So now let's discuss this first. Like, what do we mean by, so these concepts, like first concept, the other concept. So we have discussed three things. So let's make it in an order. So first we discuss this one, exponential functions, then its properties, right? Then we discuss something called natural exponential functions. In between, some concepts are there like asymptote, right? So that we discussed. Now we are going to have a fourth topic. So fourth topic is nothing but, let's start with domain, right? Finding domain. Okay, so that is very important. Finding domain of functions and composition of functions, right? So let's discuss composition of functions. So sometime what happens is, as if now we were clearly telling your function was from this interval to this interval, right? We were telling like this, right? And this was your domain, and this
Yes.
was your codomain.
Yes.
So we were actually telling you like, okay, what was your domain, right? Now we will not tell you domain, but we will rather ask you to find out its domain. Okay. So now if I have to ask you, what is the domain of the function f of x equals to 1 by x? What is the domain of this function?
X not equal to
All
0.
real numbers except 0.
Except 0.
All real numbers except 0.
So this
Zero.
is the thing.
Yes.
All of you are
Yes,
fine?
yes.
No,
Yes,
no
sir.
problem with
Yes.
this. So how do you actually come to this conclusion that this is not there? You strictly stick on, I'll tell it, I'll repeat this way. You strictly obey the definition of the functions. Okay, for this particular function, I will have to make sure this f of x is not equals to, it should not be defined, right? For any particular values. When will this function not be defined? When x is equals to 0, or let's say, right, something like this.
Yes.
Not defined, or like it goes to, let's say, some infinity or something, right? So this is that value where it is not defined, right? So this is how you will find out. Now, what will be the graph for this function? How does actually this graph look like? Now, just keep it in mind. It's something that really you don't have to know, but this is how the graph look like for this function, right?
Yes.
So when we say not defined, that means for that particular x value, you will see that there is no particular fixed value. This is your y-axis, this is your x-axis. Okay, so you see at 0, you find no value of your f of x. Now this is your f of x, suppose, right? This is also the part of it, right? At x equals to 0, this function is not defined. That means there is no any fixed value for that, right? Okay, now for this particular function, could you tell me how many asymptotes are there?
So, two, sir.
Four.
Four, sir.
Up and down.
So can you tell it 4? Or should you
Yes.
strictly
Looks like
one
4.
One is x equals to 0, another y equals to 0. These are the two asymptotes you get, right?
Yes, sir. Yes, sir.
Okay.
Yeah.
It is not
4, but
it
they are
is-
same. They are 2.
Mhm.
Two got merged with one.
How the other one is not taken?
Because line is minus infinity to positive infinity.
Because it's a one function.
Both
If
asymptote
these
line.
are two different, maybe 4, but it is only one function. So
Yeah.
only 2. What happened to Mr. Vicky?
I think he lost connection or something. He went
So
somewhere.
how was the exam?
It was okay. Yeah, it was okay. Basically, I was having a power shortage for around 25 to 30 minutes. I don't know what was the issue, but there was some issue.
Yes, sir. Almost we also lost like the time 10 to 15 minutes.
I'll just give
Same
you that
condition happened with me.
45 minutes last.
Computational thinking was tough.
Yeah, it
Yes.
was.
Yeah, stuff.
Even
But
for me.
statistics was really
There was in CT there was two particular question in which
I'm
the
really
option
happy with
like
stats.
Yeah,
I even.
stats were easy. I was not thinking that it would be that easy.
When we solve like
But maths looks lengthy, na? It took more than 1 hour. Maths.
yeah, basically, what you
Difficulty is medium only, but it's lengthy. I feel maths. I couldn't answer all the questions, maths and.
last 3 I didn't answer, and one also I think I got it wrong.
But my last questions were Venn diagram. But unfortunately,
There was a question
I'm
in
good at
maths.
Venn diagrams, but I lost. I was not having
I
time
actually
to do.
calculated it 3 times, but I still didn't
Oh.
got any answer. I got something I got as 940, but I forgot to subtract it.
So I'm lucky. I didn't waste my time.
There
No,
was a
actually,
question
that
in
was the last
mathematics.
question that I was doing.
Excuse me.
Yes.
Yeah.
There was a question in mathematics where we have to find a equation of a line which is a part of a triangle.
yes.
Yeah.
I didn't do that.
you have to
that
put the
was
value,
tough, so
right?
I thought
You
I
have to
wasn't
put the
getting
value
that
of
answer.
A in every equation. I think every equation satisfied the value of A.
Yeah,
Every equation satisfies. You have to get the slope. Slope M3 you have to find.
Slope
But
was
after
given.
getting the M3 also, I don't get the equation. I got the equation
No,
x
I
minus
didn't
1,
get
but
the.
there it's all x plus 1.
Yeah,
I think
actually,
I
that
didn't get
happened
the
with
time, so
me.
I left that
Just
question and
Oh,
went to
actually,
that
I
one.
didn't
I
get the
did have the
equation as
time, but
well.
I didn't think I marked the right answer.
which answer you want?
Oh, I just took to pick two answers at random because it was the last question I had to do. I had completed all four sections,
I
and I
marked
was
as
just checking what I
3-1.
have did
I
wrong.
marked
So
it as 3-1.
I don't know. Answer was
I
correct.
think the best approach would have been to look at the questions first because last three questions were the easiest. They were the set questions and exactly same as in the revision.
yeah, actually.
The calculation, the number of instead of number of women, we had number of IIT students. That was different, but the entire percentages and how they fell
Yeah,
into every
that
bracket,
was
everything
the
was same.
same. I
Yeah,
remember that
Did
it had
anyone solve the
6%.
triangle question?
Don't have to include the 6% students and keep at the 94% and do the
yeah,
entire
yeah.
calculation.
I actually calculated the 60% of 1000 is 60, so 940 was there. But rest after that I calculated and I got something as I
Yeah,
think
first I
200
calculated the intersection of how many students like all three subjects, and from this creating
You
a
have to
Venn diagram was easy.
Yeah, yeah.
So I
Me,
then created a Venn diagram.
I do that all.
I even created the Venn diagram, but yes, means I forgot to subtract that from the 940.
6%.
Yeah.
It was 94%, right? Like
We have to subtract
Yes.
6% because those 6% didn't like any subject.
union 94% and intersection something 25.
Sir is back, guys.
Yeah. I see like like you guys don't interact with me more, but among yourself more. Right?
It's a community forming, sir.
We are afraid of teacher.
You shouldn't be. I mean, you can just treat me just like you, like, and we can just, and then as a friend, and then then the learning can be more efficient.
Yeah, sir, you are right. Means that
Yeah.
is the more beneficial.
Even when we were in IITs, what it was, I mean, when I was a student in IIT, what it was like, professor used to teach us, okay, all that good is, but actually learning happens in the hostel. That is a fact. You just learn 10% or 20% in there, like what prof teaches, but the actual learning happens with your friends. And that's why we give more emphasis to this. You can treat me as a friend, then you will learn more. But if you treat me something like some other person,
The teacher, then we will be afraid even.
Yeah, I
So
mean,
hence this request, can we have one of the calls in the evening time, please? Because I can watch these sessions on YouTube, but then it doesn't become interactive there.
Yeah. So I think there are 2 sessions which are in the evening, right?
Today one is statistics, one is there.
So, but 4 to 6 is also during office time. 9 to this time is the most difficult to
Yeah, but
attend.
we have other subjects to like accommodate, and that's the thing.
Well, but with CT and stats, mostly during the weekdays, they would have evening sessions at around 7. At least one session used to be at 7 and one maybe at 5 o'clock. So it was easy to attend them. But with maths, even at last term, I had seen that it usually starts at least one session is at 9:30 in the morning, and the other around 2 o'clock, something like that. So.
Yeah, maybe like
Hence, just a request. On Sunday, you can have a morning session on Sunday, but if one of the weekday sessions is moved to evening.
Yeah, maybe I can speak to the team again.
Yeah, better to have a session little
Thank you,
later
sir.
in the day, sir.
Yeah.
Sir, morning on Saturdays is also fine, sir.
Okay. Yeah,
But more than mornings, we
Yes,
prefer
Saturday, Sunday, anytime is fine. It's just Monday to
sir.
Friday.
So
Yeah,
for
sure,
working people, it can be a better balance.
Correct. Okay, that is fine. Then I can actually speak to them. Maybe we can arrange something, seeing the logistics of theirs. So yeah, we can do that, something like that. Yes. So let's come to our topic here. What is the domain for this function?
Sir, all x except
Complex numbers.
Complex
Except
numbers are the
complex
domain.
numbers.
Except complex
Except
numbers.
complex numbers.
All real except complex, because for here we are taking
All non-negative numbers.
All non-negative, yes. All natural numbers.
Okay.
0
can
to
I trace-
infinity.
Yeah. 0 to infinity. This is the domain?
Sir, no, sir. 0 is not included, sir.
No,
Why
no,
0 is
minus
included?
we should not take.
Why 0 is included? What is root 0?
Included.
Sir.
Negative numbers we should not include. No?
Yeah,
Yes, that
for
is the
negative
domain.
Yes. Okay. So now this is also we got to know. So what are we doing is you see the function, you stick on to the definition of a function, then you find the domain, right? How did you tell the domain for this? By knowing where this function was defined. This function was defined for only positive values, including 0, right? That is how we got to know the domain for this. Now, similarly, could you tell me what is the domain for this part?
0 will be excluded.
0 will be
0
excluded.
will be excluded first of all. Infinity will be there.
So you can actually see there are two functions. One is this and another this as entire, right? So for this, I have to make sure that 0 to infinity. But again, when I give 0 here, this functions become not defined. So I'll have to
it
remove
gets
the 0 as
excluded.
well. Yeah. So this is one example of composition of function. Okay. This is also another example of composition. In fact, all these functions are example of composition of functions, but some looks very straightforward to you. So you say that is just a function, right? So now let's just come to this part. So now we know with this information, we can actually find what is the domain of the function. Let's take another easy one. If I give you x to the power of n, what is the domain for this function? Where n is
0 to infinity
anything.
are okay.
Basically somewhere.
All real numbers?
No.
They're all real.
So all real, right? So it's just because this is polynomial function, and
Yeah.
you would have gone through your lectures earlier, and you would
But-
have known that your polynomial function is defined for all.
Find on all R.
Right?
But range depends according to the function.
Range.
Polynomial, we are taking only
This is
natural
special case.
exponents, right? Not
They're only
rational
positive
numbers.
values.
Right. So here, no. That is what. So your n is natural.
Polynomial, yeah, only natural numbers. No?
Okay.
Non-negative exponents. Okay.
Natural numbers
No,
including
that is
0.
for the n.
That is for
That
the
is
n.
for the
Polynomial.
n. That is different. Do not get
It is R.
confused.
Okay.
For the next one,
What about
it is
this one?
only positive values.
Yes, sir. It's symmetry about.
Means for range, but not for domain. Domain, it's we can take negative and positive values, but we will get only positive values.
So now we understood for some function. So now let's build our more concepts here. Okay.
Excuse me. What if we take the function f of x as mod x?
F of x equals to mod x. Okay. Now
R.
tell me, what is the domain for this function?
Real number, sir.
R.
There are.
Do not get confused with range here. Range is fixed.
0 to infinity.
Even x also same, na? Without modulus also R.
So
only.
what does domain tells you, like what all possible values of x it can take, and what does range tell you?
Actually,
Go
excuse
ahead.
me. My question was regarding. I read in one of the slides, the professor said for a function there are two conditions. One is it must be single valued, and the other must be defined over the entire domain, right? Am I right? Can you hear
sorry?
me?
Yeah, please go ahead. Sorry, I just missed.
Yeah, for a function, there are two conditions. One is it must be single valued, and the other is it must be defined over the entire domain.
Entire domain.
Can you hear me?
Yeah, you're audible. Am I audible to you?
Yes.
Yes.
Yeah. So
So what I was saying was, for a function, there are two conditions. First,
the second condition, what do you say that it should be defined for all domain? See, again, when you say domain, it's not R, right? What in the lecture you would have seen that when it says it should be defined for all domain. So
Yes.
your domain need not be R.
No. My question is whether this is a function at all.
This one.
Yeah.
Yes, this is a function.
It's a function. Yeah.
Because it will not be single valued, right?
It is single value.
Not 1.
Okay. Sorry. Okay, I got
It is
it.
not one. It is many one actually.
The f of x will not be. Okay. I got it.
For function, we do vertical line. For 1, we do horizontal line.
Yeah,
It is
my
not one to
confusion.
many. It is not
I
one
got
to many. It's
confused
many
with
to one.
the y values. It basically for two different x values, you get one y value. So it should, I thought it was the other way around.
Yeah. All right.
Okay,
So now let's just come back to our topic, which we were discussing. So now let's discuss for what do you mean by domain of composition of function? Domain of when you have composition of function. So first, what is composition of function? So basically you have two or more function in this. So for an example, you have, let's say, e to the power of, let's say you have it something like some other function like x square. So you see, this is a composition of function. It's just because you see this is one function, e to the power of something is another function, right? So you have two functions. So when you have two or more functions in them, then it forms a composition of function, right? So right, so what is the notation for this? So you say f of some function g of x.
G of x.
So for example, which I told you just now, let's say your f of x was, let's say, e to the power of x, and g of x was x square. So how will this function composition of function look like, f of g of x? So what do you do is you basically see f of this entire thing, it says, right? So whatever,
Yes.
so you see this f of initially what was there, x, right? So when you had x, you happily substituted that value. But when you give this function g of x, so what is g
You will
of x?
substitute
X square.
x square instead of x.
So instead of x, which was here, you substitute that value and it turns out to be x square. So this is the composition of functions. Okay. So other way of writing is f of g of x. This is the other way of writing the same thing, this one, right?
Yes, sir.
Right. So for this also, how will the function look like? This itself. What about g of f of x? This is also possible, right? So how will the graph
Yes,
look
sir.
like for this one? So let's do that.
Inverse, just inverse.
So what is
E
g
square.
of
G of x to the power.
So it
e
is going
the
to be
power.
f of x is nothing but e to the power of x. So
Correct.
wherever you had that x, you just substitute that value, e to the
E to
power
the
of
power
x,
x
the whole square.
whole square.
So this can also be written as e to the power of 2x.
Yes, sir.
Clear?
Yes, sir. Yes, sir.
Okay. So now we understood some more things.
Because how graph will look like? It will look like just inverse or something like other.
For this one, how will the graph look like? Could you tell me? Like this is exponential function.
Yeah.
So now see, how will the graph look like? Again, depends upon the domain of your functions. Okay. Now, if I have to tell you that what is the graph, now look at the things which I tell you here. Now, if you have f of x is equals to x, okay, and now you have where x belongs to r, suppose, and f of x is equals to x, where x belongs to, let's say, 10 to infinity. The difference between those two graphs is, see, both the functions are same, but what am I saying is the x
domain differs. Domain differs means for first one,
Similarly,
all negative values will be included.
the
But
graph
for
for this will
second
be
one,
something like this,
yeah.
right? And for this one, the graph is not going to look like this, but rather like this. That's all. Right?
Yes.
So it goes up.
So
to
zero
infinity.
is included, or what you are saying?
Look,
10
this is
or
10
it's
to
0?
infinity. 10, 10,
Okay,
10.
okay. Yeah, then it
So
will
this
be
is
starting
so
from
you
10.
see the graph also varies, right? Depending upon the domain of this. So likewise, in your composition of function, it might appears that graph should be like this, but it may need not be like that. Why? Because the domain might vary. Then how do you actually get the domain of the composition of function is very important, right? Just to know how to draw the graph for that function, or how you can actually visualize it. So let's just think of it right now. Okay. So now we understood what do we mean by composition of function, right? Now let's do some problem like where we find the what do you say, the domain of composition of function. And why do we find the domain? Just because the graphings it becomes easier, right? So that you actually know what is its domain for that function and where that function is defined, right? So now let's see this. So now if I have to give you a function here, let's say f of x is equals to x square, and your g of x is nothing but root x. Okay. Now I'm telling you, find, okay, domain of f of g of x, or this is nothing but f of g of x, right? So
Yes,
find
sir.
the, and let's say this is nothing but your g of x. So whichever
Only else.
you can use this one, but this is what, let's say this composition of function is h of x, right? Okay. So first of all, tell me how will this h of x look like?
X.
So root x whole square.
So
Sir,
this
X
is going to
only.
be so f of g of x, right? So f of root x. So this is going to be
Yes.
x square the whole, sorry, wait, I missed it somewhere.
Root x whole
Root
square.
x whole
Root x whole
root x
square.
whole
Root x
square.
whole
I
square.
will
So
use
naturally you will tell what this is nothing but
X.
so all real are defined for this. Means
so
domain
now
space
no,
are
no, no. Now naturally if I'll just simply tell you h of x is equals to x, the natural tendency is to tell, okay, the since this is linear polynomial, its domain is R, but its domain is not R.
No,
Why?
sir, g of x
Why it is
is
not
there.
R? Why it is not R? So let's just understand this. Why it is not R? H of x, though simply if I give you something like this, h of x is x, so naturally you think like, oh, this is a polynomial function, the domain should be naturally R. But this is not just a polynomial function, it's a composition of function, right? Two
Yeah.
functions are mixed. Then its domain becomes important. Here domain is not R, then what is the domain? So let's understand.
R is positive.
First define a gx, then
A positive
So
number.
I will go in the step by step. Okay. So step number 1. So maybe we can give the heading finding domain. Finding domain of h of x.
Only positive.
Okay. So what is, how do you get this? Step number 1 says find a domain of G. Find domain of, sorry, find domain of G. Okay. Step 2 says
Find domain of f.
find domain
of fx.
No. Find range of G. Okay. And step 3 says
Yes, sir.
find
Domain of F.
Domain of F. Okay. Now, if this happens, you have 2 cases. You perform these 3 steps, then you have 2 cases. Case number 1. Case number 1 says what? If range of G, if range of G is an improper subset of domain of, let's say, domain of F, in this case, then if this is happening, then domain of f of g of x, that is nothing but your h of x, is equal to domain of g. That means the domain of f of g, or basically the domain of h of x, is equal to domain of g or g of x. Clear? So now we understood case number 1. What about case 2? So now I know this is so much English happening here. Nothing, I mean, if you're not understanding, don't worry, we'll take an example and we'll understand. Case number 2. What happens if this is not happening? If range of G is not a subset, is not an improper subset of domain of F, then what? Then what do you do? Then in this case, okay, in this case, eliminate the domain, okay, eliminate the domain of G, okay, for which we are getting, let's say, like, for which we are getting those elements in the range of G, okay, which are not in domain of F, which are not in domain of F. So basically you eliminate that value and you make sure that this condition is being fulfilled. Now, I know this is so much has happened here. So now let's just take an example for both the cases where both the cases is happening. You will do all these 3 steps for all the cases of your h of x. All these three steps has to be performed. Case 1 and case 2 is something you will find out, right? So now we understood this. I'm not going to erase this. I'm going to take one example. So let's discuss this example. Okay, let's discuss this example here. So what is the first step? It says, I'll always toggle down here and then we'll see this. So first is what you have to find out the domain of g of c. So I'll just write down this function here. Here f of x was x square.
X square.
G of x is
Square root of x.
h of x is x. If I have to just simply tell you what is the domain of h of x, you will come and write r, and that will go wrong. And I'm still sure no matter what, there will be 100 students who will be giving r as the answer and will be coming in the exam. So you see, you really have to be cautious here. Now this is your h of x, and you know your h of x is what? F of g of x, right?
Yes, sir.
F of g of x. So now what is the first step? You have to find the domain of g. So whichever is here, right? You find the domain for this, right? So what is domain of g? Step 1, what is domain of g?
0 to
Zero to
infinity.
infinity.
0 to infinity.
Domain of g is?
0 to infinity.
Okay. What is range of g? That is the next step, no? What is range of g?
0 to infinity.
That is also 0 to
Zero. Now you notice one thing. Whatever is the range of g of x, that is going input as h of x.
Yes.
Right?
Yes, sir. Yes, sir.
Clear. Whatever is the range of g of x, that is going as an input for your f of x.
F of x. Yeah.
Clear? So pay
Yeah.
attention to that. That is why then you will be able to appreciate these steps. Okay. Then what you have to find out? You have to find out what? Find
Range
the domain
of-
of f. Find the domain of f.
Yeah.
Now you have to find out the domain of f. So what is your domain of f?
Range of g.
What is domain of f?
Range of g.
This is your f of x. What is your domain of f? R.
All R.
Okay.
All R, no? Individually. Just find out individually. What is domain of f? R. Now there comes the two cases. Now, is range of g a improper subset of domain of f? Now, is it that happening?
No, sir.
Now, let's see if case 1 is being satisfied here or not. What is range? 0 to infinity of g, right? Is this a proper subset of R?
Here proper
Yes, sir.
subset means what?
Sorry, improper subset.
Yes.
all the
Yes,
elements.
yes,
Yes.
Yes, sir.
Yes, it is.
Now here I have one doubt.
Hmm.
The subset and proper subset, these two symbols are different, na? This
Yeah.
is subset symbol. No?
This is improper subset.
Improper subset.
Now proper subset, this is subset symbol, and proper subset won't have underline the line, right? Proper subset. So what you are telling here, I'm not getting. Little bit confusion.
That line under the C is equal to
Subset.
sign.
That is subset symbol. Now what we wrote, this symbol is subset.
No, C is subset sign and the line under is says equal.
No, C is proper subset symbol. Only C is proper subset symbol.
See, I'll tell you here, just understand this. So one thing, you know that what is proper subset?
Proper subset means
you know what is improper subset? Normally,
I know subset and proper subset.
I'll tell you
as of
one.
now.
Normally, subset, when we say subset, we mean this. Normally, normal case.
Yes. Okay.
Clear? Okay. Now you are fine. You don't have any doubt here.
Sir, once can you make it clear what proper subset is? Just to clear.
So yeah, fine. So now you just just a minute. I think my battery is low. Just give me 2 minutes.
But in
Okay, sir.
Proper subset is, I guess, all those means values. which
actually what we
satisfies
learned in first week, proper subset is just C symbol. That means if you take two sets, second set should have at least one element more than the first set. That is the proper subset we learned. And the
No.
subset what?
No. If I remember correctly, there were only two symbols. One with this, what is mentioned here.
Yeah.
That is
Other one was with the bar crossed out.
Yeah.
No.
Yes.
No.
Actually,
Proper
proper and
subset.
improper subsets
proper
are
is
both
C
subsets.
subject.
No?
Improper
Only C
subset is
symbol
equal
proper
set, right?
subset.
Yeah, equal set.
Improper
Yes.
set is equal
Yes.
set, right? Improper set.
True.
Yeah.
True. Proper
Yeah,
set will have
proper
extra
subset means
elements.
At least one less
at least
element,
one
right?
less
From this.
element should be
Yes,
there.
true. That
Yeah,
is proper
And
subset.
improper
means
means
the
equal to
basically
also
it's
they
not
can
equal.
have. Yeah, equal to also they can have.
Yes,
Both the
proper
set
means
has the
yes,
same
less or
elements and
more,
same
not
numbers,
equal.
no problem. That is improper.
We are having proper here, right?
But
That's
that symbol
equal.
in our
Yes.
what
No,
we
it's
learned in first
improper.
is
Yes.
proper.
That
which
symbol
is
says
only
yes.
Here is
only C
improper.
That
for
symbol
proper
says
subset.
improper, right?
Yeah.
Yeah, it's
Yes.
improper.
Symbol says equal.
Yes,
Yeah.
true.
But it is not improper,
subset.
right? It is proper.
It is proper.
I think in
This
first week it
symbol
was
what
mentioned it can be used in general, but when it's only C,
Yeah.
it can mean proper subset. So there was a
Yeah.
discussion around it. He also discussed by cancelling that equal to as another way to write it.
Yeah.
But this is the generic form that sir
Generic
had
form you
mentioned
can
in
write.
week one video.
Generally, we tend to write it like that.
So in that case, here the bar must be crossed out.
Yeah.
Yeah, we can write that way also, but this is the general form always we are using.
No. What
Yes,
he
that's
was
what sir
saying-
mentioned, and this is generally used. But if you want to be very particular about it, you remove that line, and sometimes they also cross out that line.
Yeah.
But the generic form to use it is C with that equal to line under
Equal
it.
to line.
This was discussed in one of the live sessions, I guess.
No, it's in the week one videos, Mukund
Slides
sir's
also.
videos.
That Professor Madhavan here.
in class also explained. Yes, proper subset is simple C, and subset is C underline. That means this is improper subset.
Okay, maybe I'll check.
Yes. That's correct notation.
Simple C is proper subset.
But we can write this way also. It's not a wrong
But
to
as
write
far as
this
I
way.
can remember, the first when the subset was introduced as a topic, it always came with the bar under it.
Right. So that's what Madhavan sir mentions, that this can be used generally.
Yes.
It can mean any of the two, but when you write only C, then it's a proper subset. And the other way to write is striking off that C line under
When
the
the
C.
professor went to the second slide, or when he
proper
was discussing other topic, then he came up with the crossed out bar. He never discussed only this C symbol as you said.
But later on in the classes, these instructors told to memorize that.
Yes. That's what I was saying. In the slides, there is
Classes.
nothing, only C. That I did not notice only C in the slides.
No, not in the slides. In the class, week one classes, they told.
Yeah. Okay then.
Yeah. Hi. So now I think you don't have doubt with this proper subset thing, right? It's okay.
Yes.
Okay. So now we understood that this is happening. Case one is fulfilled. If then case one is fulfilled, then what is the domain? It says what? The domain of f of g, that is h of x, is equal to domain of g of x. So what is domain of g of x?
0 to infinity.
0 to infinity.
So then I can say, therefore, domain of h of x is nothing but what?
0 to infinity.
I can say this, right? So this is case one condition. Okay, so now see that usually if this was given, you would have gone wrong. But since this is composition of these two functions, this is happening, right?
Okay.
It means basically we are never like finding the domain of f of x.
You found the domain of f of x.
Sir, when we found range of g of x, can we simply say that is the domain of f of g of x?
That is what, see again, that do not go wrong there. Then the second case comes in, case two. You will understand this better when we are doing this. Let's go with another case. Okay, let's take another example and then you will
That's
understand.
what I also thought, sir.
Yeah, so let's understand this. So now you see this, when I give you, let's say your f of x is here, let's give a bigger problem. So x square minus 8x plus 15 upon x plus 3. This is your f of x now. Okay, x plus 3.
Yes.
And let's say your g of x is root over of x square minus 4. Then you have to find the domain of, find domain of f of g of x, right? So if this is the case, what is your step one?
For f
You
of
have to
x,
find the domain of
minus 3.
domain of g of x, right? So what is domain of g of x? What is domain of g of x?
Other than 2.
Except minus 2.
Minus
If,
2.
okay,
2.
let me just tell you how do we
Before
do
2
this?
infinity.
How
R
do we do this?
minus R
How do we,
minus 1 comma minus 1.
Minus
infinity.
0
do
to
we do this?
infinity
All
other
things
than
minus
2.
2
I
and
will,
minus.
okay, just a minute. So this is going to be minus 2 and this is going to be 2 and the graph for this will be like this, right? And this has to be what? This has to be positive always. So these are those regions, right? So
Yes,
what is
yes.
domain of g of x? So domain of g of x is nothing but minus
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 infinity.
infinity to minus 2.
Minus 2 is included.
Yeah.
Union.
And 2 to infinity.
That means I cannot give this part, right?
Yeah.
From minus 2
Yes.
to 2, this value will go will always be negative, right?
Yeah.
So now we understood. Now the domain for g of x is this one. I hope this is
So
fine to
for
all of you.
graphing square root function, we should not bother about the square root.
We bothered here, no? See, that is why our domain was restricted.
No, not for domain. Graphing part I'm asking.
What
X
you
plus
have
2,
to
x
do?
minus 2, simply we took it as a x square and we draw the parabola, right? The square root we
We
no
drew
need
the
to
parabola and then we obeyed that it has to be great, because whenever you have root, you have to make sure it is greater than or equals to 0, right?
Sir, can I ask a question here? Means here you have written as minus infinity minus 2 union 2 comma infinity. Can we write it as minus infinity infinity minus r of set minus 2 and 2 not included?
Okay, so maybe like this you are telling, is it? So all are, wherein
Yeah.
this is not included from minus 2 to 2. Yeah, this is also possible.
Means that is a shorthand notation. So I just asked, sir, used actually.
Yeah, that is okay. Everybody has their way. So I hope this is fine. Now we got step 1 is done. Now let's go to step 2. What is step 2? What does it say? The range of g of x.
Range of g.
Range of g of x. What is range of g of x? Look at this graph only. Of course, this is root function, right? So it has to be from where to where?
Positive only.
0 to infinity?
0 to infinity.
Right?
What
Less
happens to
participation.
the part negative to 0?
Negative to?
0, what happens
You will
here?
get something negative.
Minus
It will be a complex
It will be
value.
complex number, right?
Okay.
Sir, how did we find the range of this function?
Range of
So
this
that
function is,
part
you see, look at this root over of something, right?
Root is means you don't have any negative values.
You don't have any negative values, right?
Yeah.
What is the least value this root can take?
0.
0. And when will this become 0? At 2 and minus 2. That is what we have seen, right?
Yes, sir.
From the
And-
graph itself, we can easily identify the reason itself.
You could have told, of course, like you could have given this value. If this was not there, then you would have told this is the least value. But you see, this function is not defined for this reason, isn't it?
Yeah.
When you have root over of that.
Yes,
That is why
yes.
this is gone. So you have starting from here to here.
2 to
Starting from here to
infinity and
infinity.
minus 2 to infinity.
I hope this is okay.
Yes.
Yes.
Yes, sir. Yes, sir.
Okay. So now what is domain of f of x? That is the third step, right? What is our domain of f of x?
All real except minus 3.
All real except minus 3.
Okay. So it is all r except minus 3. Any doubt on this?
Sir, step 3 means why it's minus 3.
Look at the function f of x.
The function will be undefined for 3.
Okay. Here we are finding for f of x. Right.
Okay. So now we will look whether, this, what is the condition? What do we do next? Case 1 and case 2, right? So whether you see that the range is a subset, or in other words, specifically, if I have to say, it is an improper subset, right? So the range is improper subset of this or not. So let's just check that. Here, this was included and infinity, of course, doesn't get included. So is this the right statement here?
No, because -3.
No, sir. -3 is not included.
-3 is removed, sir.
Sir, it could be
-3.
Sir, improper
Yes.
subset, sir.
Yes, sir.
So this is correct.
Sir, this is correct.
It's correct, sir.
Because
Yes,
minus
actually, sir.
Yes,
-3
correct,
doesn't
sir.
matter. Anyways, the range is positive.
Yeah, range is
Right.
positive.
And so R -3 will have positive values also. So this
Yes,
is
it's
a
true.
improper subset.
Yes, this is satisfied.
It's satisfied? This condition satisfied?
Yes.
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 So again, I think your case 1 comes in again here, right? So case 2 is not coming in here. So yeah, so maybe I should have given. So okay, consider this as another example of your case 1.
Sir, excuse me, sir.
Go ahead.
Sir, the step 2 where we find range of gx. So I was getting stuck in finding the range of gx.
Okay, range of g of x, right? Okay, fine. I'll just tell you that. So first, what is domain of f of g of x in this case?
The
domain of g of x itself, right? So that is
G of x itself.
So as you were using this notation, so let's use that only. Okay, so this is fine.
Yes.
Now let's go with the where we have case 2 coming in. Okay, so let's discuss that. So I think this is done. Now let's go with another wherein case 2 is coming. But before that, you had doubt here. How did we get this range, right?
Yes, sir.
Okay. So good that you asked. I think you got hesitated that time to ask because everybody was telling, yeah, understood.
Sir, there was actually some drums beating around.
Yeah, I
stage,
get it.
so
I get
just
it.
thought
I
I
get
will
it.
ask later.
Okay, so all right. So how do we get this? So first, look at this function. Okay. So you see this. There are two functions here. One is that square root, and other is that polynomial quadratic equation, right? So what we do is we'll just obey both the functions. Sure. So now look at this x square minus 4, right? So I can factorize that and write this in this form.
Yes, sir.
This is root over of this. Clear?
Yes, sir.
Yes, sir.
This is same thing, right? So I can just simply just make the graph. And why am I making graph? Just to make sure. See, this is nothing but your okay, I'll come to this, but just let's make the graph for this. How will the graph look like? This is something you get for this part.
Yes, sir.
Now look at this function. This is indicated by this, right? Only this part, not the root over. Now you see that this product, this into this is nothing but the y value, right? This gives you y value, isn't it? Let's say this is giving you y value. Now you have to make sure that this y has to be greater than or equals to 0 when it is under root.
Okay, sir.
Right? Where all it is greater than 0?
Sir, between 0 to infinity, minus infinity to -2 and 2 to plus infinity.
Right? So these are the only regions where it is greater than or equals to 0, this function, right?
Yes, sir.
And why are we doing that? Because this is a root function and I don't want to violate the definition for this, right? So that means y is greater than or equals to 0 only when in this region. And this region, for this region, what are those x values? Minus infinity to -2. And this part is not there.
Yes, sir.
Union 2 to infinity. Now look at this. This is the domain. I think you have no doubt with the domain.
Yes, sir.
Now if this is the domain, then certainly what is your range? What is your range? Range is the set of y values the function can, I mean, not the y values, but this values. Let's say this is your y1. What are the y1 values this function can take? I mean, what are the values it can take, this function y1?
0 to infinity, because when we are putting a value of x either -2 or 2, we will get infinity.
So clear?
0.
And 0 is included?
Yes, sir.
Yes, sir.
Right? So clear?
Why
Now
is
you got
infinity not
Yes,
included?
sir. Actually, what I did was I used the analytical method. I just put x square minus 4 must be greater than equal to 0. And I transferred and I got x must be greater or equal to 0, greater or equal
That is
to
also
plus
correct.
minus 2. And
Correct.
at this point I got confused.
Okay. So let's look into that part also.
Sir, why is infinity not included in range?
Because you don't know what is the infinity value.
Infinity.
That
Value
is
of infinity.
Sir,
yes.
so after we find the domain, if we substitute the domain values, we can get the idea of a range, right?
Once you get the domain, then you can actually substitute those extreme values of the domain and find the range.
Okay, sir.
If you don't have the things, right? So now you see here what happens when you take the root over case. So this is the root over, right? So when you take root over, it goes plus or minus 2.
Root 4 plus minus 2.
Right.
Plus minus
But
2.
again, how do you go ahead with this, right? Now the nature of this thing changes, right? So when you take this, it says you just cannot write just like this. You will have two cases coming in here. You would have just gone it here and you would have to go plus or minus 2, but you know this changes at that point of time.
Yes.
One
How
is
does that
greater
happen?
than 2, one is less than 2, I guess.
So you will say that x is greater
Then
than
minus 2 and greater than.
when x is greater than plus 2 and x has to be lesser than minus 2. This
Minus
condition,
2. Your function will not be defined.
this will come in.
Sir, how do we figure this out? Because usually I would try to graph and figure this out, but if we don't graph, how can we figure this out?
When you say this, so you see naturally what was the sign for this one? Plus, right? And for plus, this was happening. So for plus, let it be plus only. So when this is 2, but the moment you give it another sign to this will also change, you know.
Yes, means that
one
the
better way.
inequality
Yes,
sign
sir.
actually inverse, get inverse.
Yeah, one better way could be factorize it before sending the 4 on the other side. Like x minus 2 into x plus 2 is greater than or equal to 0. For that to be greater than or equal to 0, you can use the multiplication of signs and then figure out.
That is also fine, yeah. But since see here it was positive, when it is positive, this condition is fine. The moment you give negative, the sign changes.
Yes, sir.
Right? That is
Graphing looks much easier than this.
Yeah, more efficient and much easier.
yeah. So all right. So I think you are becoming like me. Even I do a lot of graphing, so I understand with graphics only. So good,
Yes,
like
sir, graphing is a lot easier because we can just
Graphing is
visualize
lot
the result.
No need to memorize more.
yeah.
Yeah.
That's right.
Yes, sir.
Okay, so now let's go with another. This is our question 3 on this, right? So in question 3, what you see is now let's say you have f of x is equals to 1 by x minus 3, and then let's say g of x is nothing but root over of x square minus 4. Similar case. Now you see what is the domain of your g? We have just found out. What is the domain of g?
Minus infinity to minus 2.
Minus infinity to minus 2
minus
union 2 to
2 to infinity.
what is range of g?
Range is 0 to infinity, sir.
0
Range
to
is 0 to
0 to
infinity.
infinity.
Okay. And what is now domain of f?
All are
Minus 3.
except 3. Minus
All are except
Positive 3.
positive
except
3.
3. Okay. So except positive 3. Now will come the thing. Now you tell me that is range of g of x. So basically I can just simply write down this. Is the subset of this plus 3. Yeah. Is this the case? Is this happening?
No.
No.
3 is excluded, no?
3 is excluded, sir.
That means 3 should not be there here, right? So I cannot say that this is improper subset, right? Because in this 3 is there, but here 3 is not there, right? So here this is our case 2. So what does our case 2 says? Whichever values that extras are, you have to remove from the domain of g of x, right? So now I have to make sure that my g of x is not equals to 3. Am I clear on this? I will bring that statement so that eliminate the domain of g for which we are getting those elements in the range of g which are not in the domain of f.
Yes, sir.
Okay. So now Or simply, if you did not get this statement, I have to make sure that g of x, that is the input which I am giving here. So basically, how do I write? F of g of x, right? So I have to make sure that this g of x is not 3. Right?
Okay.
Yes.
G of x is not 3, because the moment it becomes 3, it will violate the definition.
Yeah.
Right? So what I'll have to do? So what is g of x then? What is g of x? Root over of x square minus 4 should not be equals to 3. Right? So for what value it gives you 3? So again, I'll just use my graph thing. Just, we are very much fine with our graphings. So for what value I'm getting this 3? So there are two values for which I can get 3. So I can just simply exploit this, and then I can write down this. I can just square on the both sides. So you see that this should not be equals to 3. So this should not be equals to plus or minus 9, right?
Yes.
When I'm squaring.
Why plus or minus? Because
Squaring both sides.
Squaring both sides. Yeah. So now I can say that x square minus 4 should not be equals to 9, or x square minus 4 should not be equals to minus 9. So x square should not be equals to 9 plus 4 is 13, right? So basically x should not be equals to plus or minus root 13.
Yes, sir.
Right?
So it will be a decimal value, right?
Yeah, whatever value you have, but certainly I can say that x should not be equals to plus or minus, and from here what do I get? X square not be equals to, if I take to the other side, this turns out to be minus 5, is it?
Yes.
So now I will have what? X plus or minus.
right?
This is a complex
It's a
value, right?
complex one.
So I can just simply ignore this, right? So now what? That means now what is the domain of f of x? Oh, sorry, f of g of x. I have to make sure that this is not there, right? What is domain of f of g of x? So what was our initial domain of this thing? How are we finding that? G of x, right? So here, what was our g of x domain?
Minus
This part.
infinity.
So
Yes.
you were telling it like this, no? Initially, so maybe I can just, sorry. So how we were writing initially, our domain was what? If that condition was not there, minus 2 to 2 was not included, right?
Yes, sir.
In this, I'm also not including what?
Square root of 13.
Plus or minus root 13 is also not. Now this is the domain of f of g of x. I hope this is clear now.
Sir, can you explain, please, man?
Again, so I will just tell you again. Okay.
Excuse me,
so
sir.
now,
Excuse me.
Yeah.
So here, when we square the both values of under root x square minus 4 and not equals to 3, why we take plus minus 9? Because we are squaring and the initial value was positive 3.
Yeah.
Yeah, you can actually say that we don't really have to go for this part.
Because initial value was positive.
Exactly. Because when you go for under root means it can have, positive and
Negative and positive values.
So maybe this is not right to say, but yes, we can say.
Sir,
that.
can we write this final?
Sir, actually, is this the general form we solve the equations? We take plus minus when we do this kind of solving.
Yes. You can consider this as general.
Plus minus, or we just can take positive values because we just erase that whole thing.
You can take positive values and go ahead.
Sir, final domain for this h of s, can we write it as minus infinity to minus 13 and then minus 13 to 2?
Okay, so in other way around. So maybe we can
split
like
it up.
this. So maybe, So maybe I can just draw a line. How we were defining it earlier. So this is minus infinity and minus 2. And over here, this part was not defined, right? So
Yes,
here
sir.
you had from 2 to infinity, right? So this was there for us. Okay, so now we are also excluding this part. So root 13 is how much? Maybe like it will be greater than 3. It is greater than 3, but lesser than 4. So greater than
3.6.
Yeah, so that means I am not including which part? Here comes minus root 13, and here comes
Root 13
plus root 13. So now what am I doing? So I can write this. Now I'm rewriting this. Minus infinity to minus root 13. This is not included. Right?
Union.
Go ahead.
minus root 13 to minus 2 included?
Union.
Sir,
minus
it
2 is
include
included.
two.
Yes.
Yeah.
Hmm.
Union minus 2, union 2 to root 13.
Plus 13 or just
Not
simply 13?
root 13 not included.
Not included. Union 13 to infinity.
Yeah, 13 to infinity. So root 13 to infinity. Yeah, this is other way of writing it. Yes.
Thank you, sir.
Yeah, welcome. All right. So now I will just tell you again how this was done. Okay. Only this case too. Yes.
So 1 minute, sir. So just considering the earlier case of x square minus 4 not equals to 3.
Okay.
We are not squaring, we have x square under root x square minus 4. So what if we have only x square minus 1?
X square minus 1.
1, not 4. So then
X square
4
minus 1
plus minus 9 that you earlier told would had held true, and we will not get a complex number.
Okay, let's just clarify this here itself. Okay. So now what you're saying is for two values of this. So now what x square?
Minus 1 not equals to plus minus 9. So because this was the part where I really got confused, where you took that.
Let's take it as 3. Let's take it as 3. Okay. No, not 3, but let's take it as 1. Okay. So let's understand this. X square minus 1 not equals to 1. Okay. So now how will this graph look like? Okay. So now just simply let's understand this. Graphically, we'll first go through. How will the graph look like for this part? X square minus 1.
So it will get minus 1 and plus 1 as 2 roots.
So plus or minus 2 roots means it will be something like this, right?
Yeah.
So
Yes,
minus
sir.
1 and
plus
1.
1.
And now we are saying that according to our condition, this 1 is not included, right? So 1 is not included means where it was becoming 1 over here. So there were two values where it was becoming 1, right? There were two x values for which it was becoming 1, right? So I'm ignoring those two values, right? Unlike here, plus or minus root 13 I was getting, right? So now how will this graph look like? So now I'll go with just this case. So x square minus 1 plus or minus 1. Okay. So now I can just, root over. We had even root over. So maybe I can ignore this part as well, right?
Yes, sir.
Okay. So root over of this thing. So now let's understand this. When you have this root over, now I'm just squaring on the both sides. So this turns out to be x square minus 1 plus or minus 1. So this gives me x square plus or minus so this, when it goes to the other side, you get 2, right? So now you have this x square. So this will turn out to be plus or minus not equals to root 2.
Yes,
right?
sir. Yeah.
Now
sir,
let's
I
take
understand this part. Sir, I understand this part. So where in the previous solution where you have took x square minus 4 is not equals to plus minus 9.
Okay.
I got confused why we are taking minus 9, because if we are taking minus 9 after squaring, then we can get a set of values which can be possible.
I got it. I got your point. That's what I was coming here. So now let's take, this is the trivial way we did it. Now
Yes,
we'll take up the another condition. X square minus 1 when I was taking it plus or minus 1. So plus minus 1 case is done. So now when I just square it, x square minus 1, now I have what? Not equals to minus 1, suppose.
Yeah.
Right?
Yes.
Because when I took plus or minus, plus case is done here, right? So this is just, we'll take the another case, that is x square not equals to minus 1. So this will always give you what? X is square not equals to 0, or 0. X is not equals to 0, which lies somewhere here.
But sir, isn't the square of a real number always positive?
Square of a real number?
Isn't it always positive?
So you see, basically, if you are to ask me, why are we not taking minus 1, suppose that is your question. We can also take minus 1, right? Because that will give you one possible case. Isn't it?
If we start from a root, then how are we going to get a negative number as one possible case? Because when we square, we're always going to get a positive on the RHS, right?
No, yeah, that's what. So that's what I was coming to that thing. So now we have to understand from here. First of all, what she is telling is right. This case will never come in, right? So if that is the case, and then what is the other way of thinking is, because you see here it says that x should not be 3. I mean, that was the earlier case. Now here when you do root over of this thing and then you are claiming that no, it can be plus or minus 9, which is wrong assumption. So that is one thing. And another, just simply what she told is perfectly right, isn't it?
Excuse me. If you can draw a graph of a square root function, that would be very beneficial for everyone.
Yeah,
Because
Yes.
square root function is something like this.
now it's clear, right?
Yes, sir. Now it's clear. Now we have got.
So we cannot have negative values at all.
Yeah, that is also okay.
That's what she said. I mean, that's what
Yeah.
you basically you also did earlier.
Yeah, I think if you are very much fine with this, then this is okay. The graph root x is that only, that's all.
So it can't be negative, right?
It cannot
Earlier,
be negative.
when you erase that x square something is equal to minus, that would not have been the case.
So it's just that when you go like this, x square, when you come to this part, then it can have positive, negative both. But when it is root over, then you don't go with that conditions. Okay. So now let's come back to our main topic. So our main topic was here, we were discussing case 2 now, for which I gave a function f of x and g of x. And we went through our normal procedure. That is our step 1. You have to find out the domain of this. Done. You have to find out the range of g of x. Why g of x? Always g of x we are doing. It's just because this is f of g of x. So this is f of g of x, right? So that is why whatever is there inside, you do for that one. Had it been g of f of x, then you would have done reverse the process here. Okay. So now let's understand this. So now we found the domain, then we found the range, and then we have to find the domain of f of x. And then what do? We check this condition. We go with this. Is this an improper subset of this one or not? If it is, then yes, the domain of g of x is nothing but domain of your h of x or the composition function. If this is not an improper subset, then case 2 arises. And over here, we had seen that case 3 was coming in. Now, case 3 says, case 2 was coming in. So case 2 says what? When this is not there, when this is not an improper subset, right? When this is not an improper subset, then we just have to eliminate that particular values from your g of x. When you're eliminating certain values, you are actually also eliminating your x value, and x value is nothing but your domain, right? So you actually remove that x values. So basically, once that x values is removed, then you have made sure that your domain is you obtain the domain of your h of x, right? So that's what we did here. So you have to make sure that 3 is being removed, and 3 was output of your g of x. So output has to be removed. So you had done all that removing part, and then you came to say that, okay, when my x is plus or minus root 3, I get this 3. So then from my g of x, from the domain of g of x, if I remove these two x values, then certainly I will not have this 3, right? That is what we did.
Okay.
Certainly, if I remove these x values, then this 3 will not be there. So if I'm just removing that 3 values, so removing that 3 means you are actually removing your plus or minus root 3 values. So once you remove that from the domain
root
of G,
13 it's written.
Yeah, root 13. So root 13 values. So if you are removing that root 13 values, then life is done. You got your things.
Domain, yes, sir.
Okay. So now I think we are done with these two composition of functions. So now for those who are still struggling with this, no need to worry about. Just you can watch these videos, and I think even in tutorial, some of the questions are discussed like this. So you can rewatch them. They have told it in the same similar manner the way I have done. Okay. Maybe like I might have the same example or different examples, but this is all like they have also done it. And it is always good to practice multiple questions. Even you can see in your graded assignment, you will have a questions like this, wherein you will be asked to find out the domain and range of your composition of functions. So I think that is very important. This concept is really important. And this composition of function, it's worth practicing, because this will also come and haunt you in your week 7 and week 8 and your further weeks. Okay, so it's better to learn it here. So yes, I think what else we could do? I mean, I can do some another 10 problems so that you can have a good command on this, but I don't have much time, right? I have to discuss other thing also. So I leave that to you. You practice and you do it among yourself. just put it in the forum or discourse, like whichever questions you are doing, so that even others can do and learn from there. Okay, so now let's just discuss the other concept, that is inverse of a function, and let's wind up this session. Okay, and then you can give a practice to whatever is done. So now I think this concept was our fourth. Now let's discuss our fifth concept, that is inverse of a function, and we can wind our session here. How do you get the inverse of function? Okay, so now you see that, so this is another important thing. So inverse of function, what do you mean by inverse of a function? So x square, what is inverse of f of, if I say f of x is equals to x square, what is inverse of this function? How do we naturally, how do we normally do? We say, okay, this is y. How do we do? This is y and x square, and then change the variable. Then you write this as root y, or you can say that, okay, then I can change the variables and then say, okay, y is equals to root x. So root
Sir,
x
I
is y.
don't know this.
That's, I know you are struggling. Some of you are definitely struggling with this. There might be little concept wherein you will be missing out some points, and they will catch you there in your exam. So I don't want you to go just unprepared for your exams, and be prepared rather. So now you see that when you come to this part, I mean, normally how do? We just change the variable. Now we'll say that, okay, this is y is equals to x square. So how do you do normally? You say that, okay, let's this be x and this be y square, and then you solve and get the values of x, or you get the values of y. So if you are to ask, and then you will say like, okay, then y should be root x, or why not plus or minus root x? This is also something you can say, right? So, but again, that is something, again, click, it can be both, right? Plus or minus root x. But then what is the condition? What is the actual condition, and where do we actually face problem, right? So whenever you have something, stick on to the definition of the inverse of a function. So what does the inverse function says? It is again the concept of composition of function. Here it says, if f of g of x, or let me just write it in a more expanded form so that some of you don't get confused here. F of g of x is equals to g of f of x is equals to x. If this is happening, then you say that, then I can just simply say it in the way I'm telling it. Then you say that g of x is inverse of f of x, or can I also say that f of x is inverse of g of x? Yes, right? So I can do this. So now what? Then how do we actually understand this? Now you have written some complicated things. Now f of g of x is equals to g of f of x. This itself was hard to do. Now you have brought in both the things here, and you're equating to x, and then you are finding, okay, this is the way it is done. So how do we actually do this? How do we actually find the inverse of these functions? Okay, so let's just do an example. Okay, so now I'm telling that, now you assume something here when you're finding your this thing. So how do you find the questions? Like, you will always be asked, okay, find the inverse of, we always ask like this, no, find the inverse of, let's say f of x is equals to x cube. Now this is what we ask you, find the inverse of f of x equals to x cube. But then how do you actually know what is g of x, and how do we actually get that, right? Because you have written, and you are telling, you are claiming that this has to fulfill in order for it to be an inverse of a function. Then how do you do this, right? So now you create one function. Now you go with an assumption. Now what do you say? Okay, my f of x is x cube. Then what is my g of x? Let's say this is y. G of x is y. Let's say this. Okay, then what? I will take any of these pairs. Let me say I'm taking these two pairs, because I have to equate with something, right? So you always equate with this. So now what I'll say, f of g of x is equals to x. So now what? You see this, f of g of x. What is my g of x? Y is equals to x. Now I'll just substitute this value. F of y is what? Y cube?
Y cube, yes, sir.
So this gives me x.
X cube root of
x. So now what? What is my y?
Cube root
of x.
Cube root of
so
x.
I got my y as cube root of x.
Okay,
Now, but I have to
this is
make
how
sure.
we do this.
Yes. Now this is not done yet. Even if you know so much, you will still make mistake. I'll tell you, I'll catch you at one place. I'll tell you where. Now look at this. It says what? F of g of x is equals to x. We took that condition and we got our value of x. Now let's check it out, no, whether this is truly right or not, right? Now I'll take out these two pairs. What I did initially, I took this pairs. Now I'm taking out this pairs. Now let me check, is this totally right or wrong? Whether what I obtained, now here I'm claiming, no, then you say that g of x is inverse of f of x. Now I can simply say, oh, this is nothing but your g of x. Then I can happily say, okay, this is not root x. It's basically cube root of x.
Cube root x, that I only said.
Okay. Yes. Okay. So, or in other words, I can say that x to the power of 1 by 3.
1 by 3.
Okay. So now you say that, okay, so then this is my inverse of x as you are saying here. Then we say that g of x is inverse of f. So I just took one condition and then I fulfilled this, right? So now let's just verify this.
It's not inverse, right?
No, it is inverse.
It is inverse.
It's inverse, but we are just verifying. We have to verify also, like whatever the value we get, is this definitely an inverse or not? How do you verify that? Of course, you have two conditions. No, you can equate this with this, and then you can equate with this and this. This both has to be satisfied, isn't it? Now what we'll do is g of f of x is equals to x. Now let me say this is my LHS and this is my RHS. Okay. So now I'll just simply check whether this LHS is equals to RHS or not. Okay. So now what is my g of x? Oh, sorry, what is my f of x?
F of
x cube.
Cube.
So I'm just dealing with my RHS. I mean, I'm just dealing with my LHS now. Right. So g of this is x cube, right? So what is g of x cube? So you get what? Now what is y? Y is, I just have to substitute that, right? I should rather, so I should rather say this as g of, okay. So now this is going to be something like this. So what do I get from here? So I get, if I substitute that, this will be y cube. So wait, no, not y cube. I'm missing out something.
Power 1 by 3 whole cube. X power 1 by 3 whole cube.
What was your y? Now what did you get y here? Y was nothing but 1 by 3.
Power 1 by 3.
This is what we got it, right? Yeah.
Yes,
so
sir.
now what? So now what is your y? Now you're substituting that value there, right? So now if I substitute this over here, so I get x to the power of, so what is x here? X cube whole to the power of 1 by 3, and this gives me x. So my LHS is nothing but x now. And what is my RHS initially? X. So that means this is definitely an inverse of x cube. Clear? Not clear?
Second part.
Okay, I'll come to this.
Can you relate this inverse meaning with additive inverse, multiplication inverse?
Yeah.
Like what we do?
Okay. Additive inverse and multiplicative inverse, those are some different concepts. Here, inverse of it, yeah, I'll come to this. Those are different things.
This is nowhere linked with integer inverses. No. Okay.
This is function inverse, you can say. So now let's go with another example to understand this better. Okay. Now, this is the simplest one, right? So find the inverse. Now I'm telling you, find the inverse of f of x equals to x square. Now I will do it in a similar way. What I was doing initially? What is the condition?
F of x is equal to
is equals to g of f of x is equals to x. If this is satisfied, then I would say that g of x is inverse of f of x, or
so we should always get back x only.
You should always get back x. And I will tell you what is the importance of this. Why only x? I'll tell you, it has its importance in graphings. I'll tell you how. So now first, what I'll take up these two pairs, and then I will verify with these two pairs. Okay. Okay. So now what is f of g of x? So now I'm telling, okay, this is my f of x is nothing but x square. I'm just assuming my g of x
is equal to y.
Now some of you might be thinking, okay, you are giving x, but how come this is y? It should be dependent on that, right? Don't worry about it. That is why you were finding y here. Okay. So you assume that this is what is happening. Okay. And eventually you get
variable y is there.
Yeah, definitely. So now let's go with this. Now f of g of x. Now what is g of x? Y.
Y square.
So now which condition I'm taking? First condition I'm taking, let's say condition 1, and from condition 1 I get my y, right? From condition 1 what do I get? I get my y, right?
Y.
So now I am taking this. So now what is that condition? F of g of x is equals to x. Using this, I am getting my y. So what is my g of x? G of x
Is
is
y.
y. And what is f of y? So I get y square.
Y square, yes.
Y square.
Okay. Now I'm getting y only, no? So what is my y then? Y is plus or minus root x. So there are two root x values I'm getting. So one is what? Plus root x, and or
is minus.
Negative. Negative
or
root x.
minus root x. Now I have to verify whether both of them are the inverses of this or just single one, right?
Yes.
You understood what I'm telling? Whether
Yes.
this is inverse or this is inverse or both of them are inverse. That is what I have to verify, right? How do I do? I'll go with my condition 2. So let's go with our condition 2, and condition 2 tells what? G of f of
x.
F of x is equals to x. So now what do you say that? What is our, now this is something I have to say. Now I'll say like, okay, this is my LHS, this is my RHS, right? Now I'll do all with things with my LHS and I'll verify that, right? So what is my LHS here? What is G of x? What is G of x?
Is y.
Sorry, not G of x. So this is something like this. Y. What is my f of x?
X square.
F of x is x.
X square. And now I know what is my G of x. G of x is nothing but either over here, G of x is, just take it as plus. Now I'll take case 1. Case 1 says what? My G of x is root x.
Root x.
So when I take root x, let's see what happens, right? So now when G of x is this, then when I substitute this value, what do I get? Root x the whole square, which will give me x, which is nothing but my RHS. So this is perfectly fine. So case 1 says yes, root x is
Inverse of.
Yes,
Inverse
so I can
of
say that root x is
Inverse of give.
inverse of your f of x.
F of x.
Now let's go with my case 2. Case 2 is what? Basically, I can say that g of x is nothing but minus root x.
Minus root.
Now what about this? So now what? Now I'm finding what? G of f of x.
G of f of x. Yeah.
So now what is my g? Minus root over of x square. So that is nothing but x square. So what do I get from here?
Minus x. It is not.
So what I see here is LHS or simply
not equal to RHS.
Not equal to
RHS. LHS is not equals to RHS. That means this cannot be inverse, right?
Yeah.
So the only inverse is this.
Okay.
Clear? The only inverse is this. Now we understood this. Okay. So now since we are up with the time, now I'll just do up with the thing more here.
Is there any shortcut to find this inverse?
Shortcut is just simply take it, like x square means y. Now all you have to do is just do that manipulation. You can say that, okay, x is nothing but root y or plus or minus root y. But again, how do you verify that this is the one? That comes.
So
I'll tell you one thing.
Part.
How will
Sir, in case 5 part I'm missing, sir, something.
Yeah, sir.
This is where we'll get.
Yes, sir. Sir, why we are not account like minus root x ka whole square, like something?
No, it's just this, no, because where do you make the substitution? You make the substitution for x, right?
Yes, sir.
Over here, look at this. Now this is root over minus root x, right? And what is your g of x? This is your g of x. And where is your x? X is here only, no? So you'll make the substitution for x, no?
So the confusion is because of case 1.
Sorry? Yes, sir.
No, we got minus x. We got minus x.
We got minus
if we get x, then only it's inverse. We got
now
minus
what
x.
What you will do here is you will be substituting that value for x. What is the value for x here? X square, right? So when you substitute that thing here and when you solve it, you get what? Minus x. This is root over of this. This will give you x. This is minus as it is. And you find that this is not equal. That means g of x cannot, sorry, this one. this one cannot be the inverse for this function. Okay, so now you will still be struggling with this. I totally understand. There is so much things done in this 2 hour. I want you to
If you practice 2 to 3 problems, then it will be.
definitely.
Sir, in case of case 1, we can do the similar thing as case 2 now. Ki the x is substituted by x square and then, but I mean there we are squaring the whole root x, but that we did not do that in case
Okay,
of
you will
case
take
2.
it as +1.
In
Now
root, we
there
are not
shouldn't be a
taking
doubt.
negative values, no? So we
So the
can
square
write
must be inside the root.
Okay, I
X
think
square.
I made a mistake here. So it should be no. This was fine, no?
No, x square means should we take minus root x whole
Sorry,
square?
it should be like this, right? It should be plus
That's the
root
doubt.
over of x square. It was like this.
That's the doubt.
Now it should be fine, right? This is what you get, no? Like now you are substituting for x, but what is your x? X square. So you substituted this. When you solve it, you get x, right?
Sir, my issue is y is equal to plus root x or minus root x. So what y is means it is f of y, and if it is
Y
f
is your
of
g
y,
of x. Y is your g of x, and that g of x is nothing but inverse of that function.
okay. So that's why we are substituting g of x is equal to root x. It is not f of y.
Yeah.
Okay.
Okay, so now those who are still struggling, do watch this video again. That will help you out. Okay. And now I just want to give you an emphasis to one more thing. So now I think this is okay for you. Now look at the graph for this. How will the graph look like? Okay, for both the cases. I just want you to understand with the graphing here, right? So as I was telling you, f of x was initially x cube. And what was your g of x? G of x is nothing but the inverse of this. So inverse is indicated like this also, or g of x you can write in this way also. That is also permitted, right? So what was we were getting? We were getting cube root of x. So now if I have to draw the graph for this, okay, so you know that x cube is what? It goes something like this or something, yeah, like this.
2/3, yes, sir.
So this is your x cube. What about root of this, right? So root of this is, now whenever you draw the root of that thing, you just make the symmetric around y equals to x. Now this is a line, y is equals to x, okay? Now you just make a symmetric around this. So now how do you get that symmetric? Now maybe if I can use another color.
1/3 quarter. 4th.
So you see image of this along.
Yeah.
So this part, this is nothing but your cube root of x. So now what is the importance? Why we were taking y equals to x? Why we were equating it with this x? Because now you make an understanding here.
How it is different from minus f of x graph?
Minus f of x. I will do that. I'll come to that. Inverse functions are symmetric
about y is equal to x, no?
Symmetric about y is equals to x. So now in your that graphing thing, you can understand when it is an even function, or sorry, when it is an even function, then that will be symmetric around y axis. When it is an odd function, it is symmetric about origin. And when it is an inverse function, it is symmetric about y is equal to x. Okay, clear?
Yeah.
So maybe I can just write it down here. Inverse functions are symmetric about y is equals to x. Then even functions are symmetric about y axis. And odd functions are symmetric about origin. So now I have this 3 conclusions. This is very handy. You can put it in your notes wherever you write. So you can keep this with you. Now similarly, now here comes the big twist. Now we understood that. So now we are fine with this. Cube 2 we are done. What about the other example we took, x square, right? So now let's understand that. Maybe I can just do this. How will the graph look like for x square? So it is something like this.
Yeah.
This is my x square. Now what about my x? What about this? Square root of this. So I know that this is y is equals to x, something like this.
Yeah.
This is y is equals to, this is my symmetric line. Now what am I going to do is, How will I get the graph for?
Okay, so it will be like.
It will be like this.
Yeah.
Symmetrical. But why am I not taking this part? Why am I not taking that part? It's just
Because
because
square root is negative.
you just
means
proved
negative
it.
not defined.
The negative root of x is not defined. I mean, it's not the inverse of this, right? That
And
is
the
why
other,
this is your root x.
Okay.
I hope this is clear.
So you're only taking
Now,
the image of the positive part, sir?
Only positive part.
Okay.
Because that is only the inverse of that, no? So now I think this is okay for you. Now, could you tell me what is the domain of inverse of x square? Too much?
Sir, 0 to
Greater than or
0
equal
to
to 0?
infinity.
0 to
To
infinity.
infinity.
0 to infinity.
What is the
0
domain
to
of, okay, what is the domain of inverse of x cube?
Real line.
That is also
For all
Real
line.
line.
All real numbers.
All real lines. So I hope this is clear to all of you. Clear?
Sir,
All
I
clear?
am having
Yes, sir.
confusion with means how to verify.
Please, domain, can you please repeat?
Okay, which one? Which domain
Domains?
you want? X, this one or this one?
Here, right side.
Right side one. Okay. So you see that the inverse of x square is nothing but root x. And
Yes.
simply look at your root x function. Root x is defined for positive values, including
Only
0.
for, yeah, 0 and positive
From
values.
0 to infinity, and that's
Yeah.
okay.
And
I
what
hope
about
cube
domain
root
of
can take negative
qubit
values, sir.
cube root. Cube root is R.
So can we say that the domain of inverse of f is equal to the range of
One person. Oh,
f
just
of
a minute.
x?
Just a minute. You unmute yourself. I'll mute everyone. You
You can
unmute
say
everyone.
that.
Go ahead. Yeah, you speak now.
Yeah. So can we say that the domain of inverse of f is equal to the range of f of x?
You can say that. But could you repeat again? Just missed it. The domain of
So the domain of inverse of f, is it equal to the range of f of x?
Yes, sir. It will be yes, true,
yeah,
na, sir.
that
Yeah.
is definitely true.
It will
It
always
is also clear from this graph, you can see, right?
Yeah,
Sir,
yeah.
From this graph.
definition also clears it, right?
Generalize it for all f of
Yes,
x.
that is perfectly right. So now I think this is all okay, and let me think if I am missing out anything that I want to tell you. There is something I missed. I did not tell you the horizontal and vertical line
Sir,
test, which is given in your lecture, and see it.
I have it out in 1-1 and 1-2, like 1-to-1 functions. So once this is done, maybe I can ask that.
Just tell me. Yes, tell me. It's done.
Yeah. So that was an activity question, like activity 5.1. There was a question asking if f of x1 is not equal to f of x2 and x1 not equals to x2, that is 1-to-1. But then can we also say that if f of x1 equals f of x2 and that implies x1 equals x2, then the function is 1-to-1?
No, you cannot say that, because that is, you have some conditions for that.
Oh, okay. Why can't we say that?
It's just, see, I should give you some contradictory example for this in order to tell this, but I cannot recollect it right now, but that is not right.
Okay.
Yeah. So you can actually think of, but stick on to one definition. It says no, f of x1 is not equals to f of x2. Then you can say that x1 is not equals to x2, right? But the other way around is not always true. You have one example. I remember doing that, but that is not always true. So just stick on to one definition.
Okay. Thank you.
Yeah.
Excuse me.
Sir?
Yeah.
Going to the previous
Can
point,
you
you
also
said
discuss that constant compounding part from natural exponentiation function?
Oh, you want to discuss now? Yes, go ahead.
Can you discuss it, sir? Because I didn't understand it.
Before that, can you
functions.
Natural
please
exponential function, and in lecture 5.5, I think sir discusses the constant compounding part.
Constant compound in parts.
No, he discusses constant That is compounding. like calculating interest, which as the power tends to infinity, the value tends to e. Yes, sir, that one.
before that, can you please explain here one
Okay,
point?
that one that you will better understand when you are learning limits, so you can just avoid that for time being.
Okay, sir. Thank you.
Before that, I have one doubt here.
Yes, please go ahead.
When comes to the odd function, this left side part, this minus f of x graph also looks similar, right? Like f dash x.
Could you come again? Which one?
Minus f of x. Minus f of x.
Minus f of x.
Odd
Minus f of
function.
x. for the left function, for the left one?
Yes, yes. Odd degree polynomial.
Okay, so now let's
It's
do
a
that
cube.
thing here itself. So now you
Second.
see that. Now I think here, over here, all these things are fine. Okay. So now I'll come to this part where you are always asking this, when you have f of x, and then what if you have minus f of x, right? So now let's take this, your f of x is x cube. Okay. So how does the graph look like for x cube? Something like this. What about minus f of x cube?
Same graph.
The graph is no. Something like this.
It is looking like that. Yes, yes, yes.
So do not get confused there. Okay. So this is your f of x. This is your minus f of x. What about inverse of this?
Inverse is other thing. Yes, sir.
That is different. That is symmetric about this.
Okay. Minus f of x is symmetric about y-axis.
So all right. So this is all for today's session.
Sir, so inverses are just
I have one doubt, sir.
Go ahead.
Sir,
Sir,
can you
inverse.
explain what is in the one lecture that sir had said that without loss of any generality? What does it mean, sir?
Without loss of any generality.
In the, I think in third or fourth lecture, sir has said that without loss of any generality. What does it mean in mathematics, sir?
In context of what he was telling, without loss of generality.
In exponential function in the third or fourth lecture, sir.
Maybe like I forgot like what he has done in there.
Sir, can we leave now?
You can leave. I'm done.
Excuse me, sir.
I mean, even
Okay.
I'll leave. Yeah.
Sir?
Yeah. Go ahead.
Sir,
Sorry, I just missed that part. I haven't. I did not like. It's been a long since I've seen the lecture. So maybe like put it in a forum. We'll take.
Okay,
it.
sir. Okay,
Yeah?
sir.
Or
Okay.
like you just rewatch it. I think you might get it like what he meant.
Okay, sir.
Yeah.
Okay.
Yeah.
Thank you, sir.
You're welcome. Yeah. Yes.
Sir,
Yes. Please.
it's a query, not a doubt.
Yeah,
So
man.
here currently we are going through our 11th and 12th mathematics. Sir, so do we have to study higher engineering mathematics?
Yes. You will be doing it, no, in Maths 2 when you go to Maths 2.
So it will be high in like Taylor function or
You have it, but
like
you
that.
see, like you see, basically like what we learn in even in our undergrads, right? Those are not sufficient mathematics. I mean, if you want to really do it in depth, you really have to do some kind of PhD and some kind of specialization there, right? So what is important to us is what is required for this particular degree, like what part of mathematics we really have to focus on. Only that will deal. Okay.
So
That is
because
what
we are having some machine learning foundations, and then we will study some search methods for AI.
Whatever it is there in your machine learning part, no, we have definitely made sure that you have it in mathematics, so that you do not. You will actually find once you are done with your Maths 1 and Maths 2, right? You will find
Yes, sir.
engineering, your this thing ML foundation courses. You'll find some of its weeks are very much similar to Maths 2.
Okay, sir.
Yeah, so no worries. Like we definitely, and also the committee, they had definitely made sure that it goes in accordance. It's nothing which is being thought for no reason. Everything has a reason.
Sir, the course is industry standard, means for ML course, is it what is
Yes.
being used in
You can
industry?
trust on this. You will actually get industry-based assignments, questions as you
Okay.
go ahead during these courses. You will also get a mini projects. Certainly, you have various internships and all that things. So definitely,
Yes,
this is not just because see this requires complete practical application. This course is like that, right? Data science about that.
Yes, sir.
It's not
I also
theory.
have one general query. May I?
Yeah. Go ahead. Cindy.
Actually, my requirement is business analytics. I don't want, my focus is not much in data science because right now I'm in 35. Until the degree complete, I don't know, I may reach into 40s. So data science, the competition will be more. I cannot compete with the youngsters. So my main focus is business analytics.
Okay.
So what I should do, that
You
means
can choose your
this
elective
match
courses.
later on.
Later on, you can choose your elective courses.
But
which
this
is more
first two terms, there is
you
no
have
option.
to learn. You have to learn.
Because this mathematical part, this is much for data science only, right? Business analytics doesn't need this much mathematics.
I get it. Yeah. So, like, understand that.
Because statistics is needed for business analytics, but maths is not much needed. Na? Maths is for data science, core data science.
Right. Maybe like to understand some, something related to mathematics things, or if you want to understand something, some equations or some models or something, like this maths will be helpful at that point of
Now,
time.
it's good to learn, but I think this much depth knowledge is not needed, I think, right, for business analytics.
For business analytics, you don't require it actually. Statistics you require, graphing also you require, area under curve also you require, but for business analytics, you are basically creating dashboards, right? So basically the graphing part you can look on, and also those statistical parts.
But this maths will be there only for the first year, na? For these 2 terms, maths 1, maths 2. That's it.
Yeah, you can say that.
And to add here, Sandhya, I had attended orientation sessions in December. There it was mentioned even for stats, doing maths 2 first is important. You can do it either together or finish maths 2. It is not a prerequisite, but if you finish maths 2, then stats 2 will be easier. So
Because
somehow I think it is really, so much of maths is somehow related to the stats stuff.
I think machine learning courses are mostly mathematics based.
Right. Machine learning foundation is more about maths and stats. I mean, that is the prerequisite for your machine learning foundation. You need to do your maths 2 and maths 1.
Sir, yeah, you have to complete all the 8 courses for diploma,
and you
right?
cannot do maths 2 without maths 1. You cannot do stats 2 without stats 1. So it's like
it is given.
And in the orientation session, they said that even for stats 2, though maths 2 is not a prerequisite, but it is preferred that you do it together, or you finish your maths 2 before you take stats 2, so that stats 2 will become easier.
Yeah, right.
Otherwise, there'll be some struggle if you haven't done maths 2.
Right. Because in stats, it's not just.
I was having a question.
Hello?
The question is that means what is the means how to structure means for 2 subjects. Suppose I am taking 2 subjects. So means what subjects can I take so it can go means very easily for me? Like they said, no, mathematics 2 and stats 2. So is there any something like that? Like CT and Python we can take together. It will be helpful.
Yeah.
No, you cannot take CT and Python together. You have to finish your CT before you take Python.
Yes, yes. Sir, I have one,
like once you
just want to, yeah, actually, I am also facing the same problem actually now. I am 78 born. So I can manage maths, stats, both, but almost 20 years over. So I'm finding little difficulty in time management. But but the thing is that I can manage maths and stats. It's not that I cannot do it.
Krishnaji, I want to ask you, how about your performance?
Yeah, even I wanted to ask you. Yeah, how did you do your quiz?
No. It was actually you have already given all the questions actually, so you should not ask this. Actually, in the last session you had given almost for 40 marks. You have already given disclosed. So
in fact, more than that. Yes.
More than that actually. Yeah. Actually, this time statistics was very easy compared to qualifier.
We cannot say it as easy. No, it's not easy, but conceptual oriented. Focus.
Yeah, actually, I am a term student.
Okay.
Yeah, I am term student, but if you compare the previous qualifier, they had given lot of like mock test only. And this much support was not there. I mean, it was not there. So we found it difficult. But this time it was quiz was okay. But my only doubt is now I am not able to focus both work and because thing is that it is increasing, and now work from home option is also slowly they are removing. So
yeah.
How to manage, because the thing is that the time is only the constraint actually. Match 2 also I just went through the portion. I can manage, but I have to take one subject at a time. That is too long duration actually.
You can take only 2 means your score is valid for 1 year, right? So if there is any means there is a little work,
that is
not
a problem.
No, that is not his
not
question. His question was different.
Term student. He's already term student.
Okay.
There is the concerns actually. If you can little bit extend the time by reducing the marks, no, you give so that
Exam
the
time. He is
students all
asking about exam time.
yeah, the youngsters means the person who are students, they should not feel bad, so let them score
Yes.
more, and the people who opt for extra time, let them factor it by 0.8 or 0.75 something, then it will be helpful. Actually, we can take 3 subject and we can start clearing off, because our intention is not to go for very high score and all. We want to clear the subject and move ahead.
Right.
You know, for me also, the maths exam was really good, but I couldn't attempt because I don't have sufficient time. I'm good at Venn diagrams, but I don't have time to attempt.
Same.
No, actually, this is one thing which they have to consider. Actually, means they can give they can reduce the marks for people who opt for higher means more duration.
And sir, I want to make a request for sir at least one full mock, sir, with 4 subject.
And now, especially we are losing time in test,
And
in the settings, everything we are
Vicky ji,
losing time.
I am just I just
There
want
is
to
also a power shortage there. Means in my
Internet disconnection.
Yeah. It was happening for me also.
Yeah, I want to just add because I am planning to do it in a little bit a negative way. Now I want to deliberately want to fail in English too, so that maths too. No, maths too, because I need time for maths too. You know, because there is no point in clearing easy subject because I want to do, because there is no point. I want to deliberately fail in English too, so that during maths too I will get some more time.
This is the most unique way I have heard.
No, because there is no, we have already requested and no response.
You know,
Actually,
I'll definitely.
No, I don't get why you have to fail in English too. You can simply take maths too again, right?
well, then we will be having only 1.5 hours.
Yeah.
So then you can take English again to improve your marks. So you can just
Then I have to pay
time.
more, no? Then I have to pay
Yes,
more, no?
he needs more time. That's why he took subjects more, but he attempted only one.
That's the only option.
Sorry, why is that?
Yeah, I
Because
get it now.
yeah, just think about these things, because or you make it even, no? Any subject you start, you cannot within 1 hour you have to end. Then it will be more even for everyone.
Yeah, right. Valid point, Krishna ji. Maybe I'll speak to them.
Yeah,
And let
because
me see,
you can
like,
also
what they can do.
incentivize. You can also incentivize who are very
Correct.
smart, no? Who can finish in 45 minutes. You give like giving bonus marks. You give more than 100 marks also.
No, if they are too much, if they are youngsters
okay.
and too much smart, they will be in IIT only, na? Why
No,
they
no,
would
no,
do this?
no, no, no. We should not envy. I am not trying to envy anything. What I am trying to tell is, for people who are very smart, also you give more than 100 marks. Also, that is not a problem. Who can finish in 45 minutes? That is also fine. But there should be little, because this is not a competitive course. Here there is no cap for admission. No, you don't have a fixed admission. So just think in those lines, because once we are all going to the exam and taking, so we cannot do any fake and all. We have to
And
sit
this
in the
time,
exam.
especially this
We have
time,
to
we should
solve.
appreciate. We should appreciate stats team, because we
No, we have to really
finished stats in 1 hour exactly. We
Yes.
finished it because that is
Yes.
actually we need
No,
conceptualization more than calculations.
45 minutes.
Calculations Excel is
No,
there.
stats was Vicky ji, stats
Yeah,
and
very
maths
easy,
was really this time it
Lengthy.
was
CT also
it was
lengthy. CT also lengthy. Maths also
okay.
lengthy.
If one subject is lengthy, we can manage, but
Two.
both were
CT and maths both.
No. What I just want to
maths
add
was
here
almost
that we
all the question was given actually before the exam itself. They gave only the number was changed, so I think
Yeah.
nobody should complain on maths and stats. Even stats are also whole numbers. Everything was nicely. We can do it with hand itself. No need of calculator also.
I just have a one suggestion here. Like we do have a bonus mark here. So if in maths 1 we just pass our maths 1 with 40 marks, then we would, and we also have a bonus mark. So then we participated in
bonus marks.
No,
is
bonus
right,
marks
actually.
again. It's not a equal. I had this discussion with on I think last
bonus
week.
marks also you can grade it in the exam itself. No, people who wants
Yes,
to
but then
finish
it is
fast. they can take bonus mark if they means you can make some 45 minutes one slab, 1 hour 30 minutes one slab, 2 hours one slab. So you can little bit factor the people who finish it in 45 minutes. You make it 1.1 times the correct answer.
No. I'm just saying that
is different bonus mark they
you just
yeah, you don't because
attempt
here
the
people
students
they have their own community. They go to college, they discuss, and they do the graded assignments. They do the
I'm just
Yeah,
saying that you
that's
just
true.
attempt for 40 marks
That's
in
true.
And I
each
am also in
subject.
construction industry. I am
get-
not in touch with computer science. For me, even CT also was difficult actually. But anyway, I qualified last time. That's fine. But I'm taking one subject, two subject at a time. It's lengthy. By the time I finish, it will be
Yeah,
even.
it's understandable. Yeah, definitely will. Tomorrow itself, like we have a meeting, so maybe I'll raise.
Please consider, but it's not that because this way you can also, for example, if a person is weak in statistics, he can opt for 2 hours and he can clear it with 45, 50 marks and move to next this one rather than stuck and waiting for another 3-4 months. By the time he will have different priorities, he will lose interest actually. Means there is high chance.
Yeah,
and one issue I believe, I don't know if others are facing the same, but after a gap, when you get back to studies, the calculations are not that fast because we've not been doing that. I mean, some people might be doing that in their work, but I, for example, don't do that. I haven't done that. So the concepts are easier for me to understand. I could solve the word problems and everything, but when it actually comes to calculations, it takes me time. Sometimes there are some silly mistakes because it will get better with practice.
Actually, I will just tell one example. Actually, when I drew the graph, left side 0, -1, -2, like that, I was plotting. Once I get that roots, it was I just plotted after 0, 4, 3, 2, 1, like that. So. So this was very silly, but
means your graph was wrong.
Same. For example, even for me, there was one
what
g
I
of
mean to
x
say
is
is,
equal to.
by the time I could recollect, oh, I made this mistake. Well, means once you draw a straight line, horizontal line, then left side -1, -2. But once you get the roots 4, 3, 2, 1, I just after 0, I made 4, 3, 2, 1. So
yeah, what she said was right. The stats paper was set very correctly. I mean, you could finish it off in 1 hour.
Conceptually,
Yes, if you get the concept right, there was not much calculation to do. It was in
After
whole
question
numbers
number
and
4, I
integers.
don't
no,
think
this
there
is the
was
way
any
they should
logical
actually stats have they have lesson learned. They have improved a lot actually.
So it's maybe it's
last
not
time it was
about
difficult.
competence or anything. It is basically
Quiz 2, maybe
setting
there
the
will be more
questions
problem.
in time with in proportion to the time.
And actually, sir, we want to appreciate without this this online support, no, 100% impossible. By just looking at the videos, no, it's
I absolutely agree.
impossible. This I will just
So
want to
what
be
is
very.
missing is that practice between that graded and the final test. I also found it difficult. You will do graded at your own pace. You will not time it in exactly 1 hour.
And we also
when you
have a
come
lot
to
of
the
references,
exam, it will
no?
be difficult.
Yeah, that's why we give you
true.
mocks.
No, I
Yes,
timed it
we do have a
actually for
time
1 hour.
constraint. Always
In
we
maths, I draw everything, but what I did, turning points, I got 1 positive, 1 negative, 2 turning points, x coordinates. But when
No,
I get
means
into the
it was
options,
not there.
I interpreted wrongly. Instead of x
Okay.
coordinates, I'm thinking as x intercept, and I tick the option for MSQ.
Hello.
So I
All
will
these
get
things
0
requires
marks
a
for that
practice.
question.
No,
So,
actually,
to,
this is okay. This is a learning, but definitely.
Time, because of the time constraint.
No. It's again,
Because of
see,
time constraint.
time is, see, if you can make the graph, right, it doesn't take 1 minute to draw the graph for this. And it takes another few seconds to answer that question. And if
Yeah,
you're
sir.
making wrong, it's something. What is the error is you are lacking practice.
Yeah,
And
true.
So,
That's what I said.
I agree with.
Give an example here, like last time's qualifier exam was difficult than the current one, but it was more concept based. There were not too many calculations that we had to do. So I could finish it in there were some answers, of course, they were right in my face, but I didn't know that's the answer. But at least I could get to them. I knew that even if I did not get marks for them, and I could finish in 1 hour 15 minutes. I could, even after not solving some of them, and go back and check my answers. Here, this time the concepts were clear, much more clearer this time, but there was so much of calculation. It took so much of time. It took me
in
1.5 hours to complete maths, and then I did not get a chance to go back and check my answers.
Go
But then
back is
again,
no
I took,
matter. No time to go back here. No time
but
at all.
but then
to go
again, sir,
back.
there was
But
one more issue which I discussed in the beginning of the class, that I took some good 10-15 minutes I had to take to settle. I did not get the papers on time, so I had to go back to English and then come back to maths, because I couldn't start maths without the rough paper. So those were the issues that I had to settle
Was
down.
there any
But
power
I
shortage or
couldn't go back
internet
and
issue?
check my answers.
Computational
That was the
suggestion
concern.
I want to make.
And that is very
CT is
important when you
lengthy.
don't have much of a practice. You would really want to go back and check your answers if you have not done any silly mistakes.
Yeah, basically this is a self-paced course. That's why we are discussing those notes here. In JEE
1
mains,
hour is not enough
we
for
are
CT,
not
sir.
Yeah.
Actually, one
Actually,
more
na,
suggestion, sir.
if one subject is lengthy, we can manage. If
Manage.
two subjects are lengthy, we cannot actually.
Maths and CT both were lengthy actually.
Yes.
Maths was lengthy.
Oh,
Yeah,
Maths was
Calculations.
lengthy.
I didn't
What
think
For
that
someone
calculations?
who's
maths
not
was lengthy and
What
CT was.
calculations? Could you tell me which question
It
had
will.
more calculations?
It may took 1 hour 15 minutes. If you are
Tell
good
me.
at
I did
maths,
it in
it will
Yes.
took
45
1 hour
minutes.
Tell me
15
which
minutes.
question was like very lengthy to you.
The question
No,
that
sir,
took me most time is where I made a
this question
mistake.
paper is okay, but what if we did not know the kind of questions or exactly the questions? Then it would have been very tough. Because we
But
already
still,
knew
Even
it will
tougher.
take.
half of the
It will
question.
take 1 hour 15 minutes. It will take 1
It's
hour
just a
15
matter of
minutes. I think.
practice. If we
I don't
practice a
think so.
lot,
It take that
because
much.
English was over in like 20-25 minutes, so we could manage the subject. But
Exactly. If English was also tough,
if
it would have
English
been
was
difficult.
also lengthy, it would have been impossible.
And on top of that, we
English
lost
was
20 minutes in our center because the server got disconnected.
Yes, sir. Same
Everywhere this
problem.
happened. Everywhere this happened.
Sir,
So
one
And
small
English
consider this.
suggestion.
No, consider this. If English was tough and if you did not know the maths questions in advance, and if somehow stats also the calculations were lengthier, it would have been very difficult.
Actually,
If Mr. Vicky
almost 2 hours
if
for
Mr.
CT.
Vicky won't help, we ended up in confusion in the exam hall. Really.
No, actually,
Vicky
one
helped
thing,
us
sir, we have
really.
to appreciate all the team, this staff support team, no,
True,
for
true.
stats,
True.
stats and maths, everybody. There are without them, definitely we cannot move forward. With this is
it's a big point.
No doubt. No
yeah,
doubt.
no, we cannot
Learning much better than classroom.
videos. Yeah, videos. Yes.
Yeah, one suggestion could be after graded, you could give some optional practice assignments. That is choice. If the student wants to practice, they can. Otherwise, it's all right. But you can give some higher difficulty
guess,
level practice questions after the graded.
I guess
actually,
we will
one more
implement
suggestion,
it.
sir. I made one small mistake. I took first qualifier in first attempt. I couldn't qualify because of 1 mark, 2% I lost. But that time, what happened was there are in that button, no, the TCS button, there are 2 purple buttons. You tell them to change the code. Actually, I selected the purple button. There are 2 buttons actually. One is purple button, one is purple with green. If purple with green means it registers our answer.
Review.
I had
Is
pressed
it so?
only
I
the
don't know. I kept
yes.
many under review. It will take review answers.
Review means it won't take.
There are 2 ways
2 buttons.
There are 2
buttons.
ways
That is
to put answers for review. One is by not
green
answering,
button.
and one is
one.
answering and keeping it for review.
Yeah, that is the confusion.
It
Main
was
thing is
given in the instructions.
yeah.
If
No.
there
That
was
nobody
purple
will
and green, then your answer will be reviewed. Else, it will not be reviewed.
Yes,
green is 100%. It will take. Purple with green is it will take. But I had selected only purple in that maths. Almost 4 to 5
Purple means
answers.
if you won't keep answer, it will be there only, na?
No. It won't get registered in that system.
They
So
did
it will
not
become blank.
They will not take it means for grade.
Like traffic signal, some other color. If they put means it is easy because I got
many like that. I kept many like that. I'm thinking wherever we will keep the answer, it will take.
No. It will means purple and then in
purple with
there will be
green,
a green.
purple with green and green. Only 2 buttons it will register actually. In the first qualifier, what I made mistake was only purple I kept and almost 5 answers got blank, and I missed only by 1 mark.
Excuse me.
It was given in the instruction at the starting when we have to read that.
See, when you are in the, it's very hard.
If you
First
keep
time it is very
answer,
hard.
if you
Why
keep
they
answer,
cannot
it will
keep a different
automatically
color?
go to purple and green, na? If you answer it.
Answer it green, it will go. But if you keep it for review and if you want to come back,
There is a button for answer and review. If you have clicked that, then it will be considered for grading. Else
but
it will
don't
not be
keep
considered
both
for grading.
purple, sir. Purple, you change one purple to some red color or something so that it is eye catching.
Yeah, sir.
Yeah.
I left many questions
Green,
like that. I
orange,
don't know.
red. Yeah, green, red, and yellow.
One more thing, sir. Last one.
Yeah,
Sorry, I'm
yeah.
taking a bit.
No, it's okay.
More than 9:30, can you keep it from 8:30? At least we can ask for 1 hour permission and we can attend the this one.
Doable,
Yeah. Oh, okay.
This
Early
can
morning.
be implemented. Yeah. This can be implemented soon.
8:30 is okay. 8:30 to 9:30. Then we can ask for 1 hour permission and we can. Because sometimes it's very difficult to tell to office also, no? It's not,
Sure.
yeah. Okay, thank you.
Yeah, thank you.
I wanted to.
Yeah. Go
Sir,
ahead.
I want to just know that how our BSc degree is different from BTech, sir. BTech CSE, like how many difference between them?
One thing is like it's a 4-year course. This is 3-year course. Other thing is like this is more you know you can say this is more specialized. In BTech in first year you will see like you will do all kind of courses. It's not just your it's not just your computer science. Let's say if you take computer science, in first year you'll have to do your some courses of mechanical engineering, something with biotech, civil. The first year is like that. And then from the second year it starts. But here in BSc degree you don't have anything as such. It's starting from the day
This
one.
is a specialization course, type of a specialization
So in
course
BTech,
later on.
in first year you will do engineering courses of all the subjects. I mean, of all the departments. It's like that.
Basically,
I mean,
all the departments.
Yeah, you even have to learn something with law. So Indian Constitution. Then something like mechanical engineering, electrical engineering, all subjects like this. Physics, chemistry. You have lab for this, no matter which department you are from. So this is something is there. So the first year is something like that, right? And then from second year you go into your department, the actual department where your actual courses starts. So that is again 3 years, and here we are starting from that. So this is 3 years.
Sir, I was also having a question. Means this IIT, this means what we will get the degree is from IIT, right?
Yes.
So it's acceptable everywhere. So we will be called IITians like that.
Yeah, definitely. I mean,
we will be alumnus of
I'm
IIT
telling you one
Madras,
thing.
or...
You complete this 3 years of course. You do with your BSc degree. I mean, get your BSc degree. You yourself will find yourself valuable. You'll be like, yeah, I know something. I have some tools by which I can do something. It shouldn't. You yourself can claim that, I'm professional with this field. I can do something with this now. Right? And that is something it should have. I mean, I would definitely tell you in our education system, like if you are from, let's say if you are doing your engineering, there are so many engineering colleges where you will do nothing, right? And you will be called engineer with no skills, nothing as such, right?
Yes.
Right? What is the whole point? I mean, that's how we have unemployment. Now, just imagine if nothing happens. At least now you know things with yourself. Now you have learned something. Now you have, see, what it matters is your skills at the end, right? And this is something skill based. Now you have something tools. Like if you want to work, you need some tools. Now you have some tools with you right now. If nothing happens, you can start something with your own. At least that is also you can do. So what happens is like you should know something. Like, yeah, I know something. At the end, when you're coming out from this, you are graduating from this, you yourself will feel that, yeah, I'm good with this field. I can do something with this. That is very much essential. You will be confident in yourself. Like even if you are interviewed anywhere, you'll be like, yeah, I know something. Plus, you'll be backed with a degree from IIT Madras. What else you want? You have a knowledge. You have a degree.
After qualifying,
and one more thing. And one more thing I want to add. One more thing I want to add. The alumni of IITs are very strong, right? So you'll be part of the alumni of IIT Madras. So what I'm trying to say is, now since you're a part of the alum, and the alums actually gives you always some kind of opportunities, like that is always there with you. So you will have the access to this. See, even I am the alum of IIT Madras, I always get this opportunity saying that, yeah, there is an opening here, with these vacancies. So that is posted only in our alumni network, right? And since you are the part of network, you always have the opportunity. And see,
So
another thing I'll
when
tell
you
you.
will become that part, means
Yeah, you
just
become
after
a
the
part of this.
qualifier, or
Plus, I'll tell you one thing, one more thing. You are not just part of IIT Madras, but you also are bifurcating from there in something. You are creating IIT Madras BSc degree program. So you yourself is a big giant, you know, it's like 10,000 plus students. It's a whole parallel virtual IIT is running, you know, that this is a very
yeah,
big
you can
thing.
say that.
So
Means
you have
thanks
advantage both
for.
the way. And you
Okay,
see,
okay.
maybe you will not find its advantage right now, right away. But you see, after 5 years, you're like big giant, you know, like you have a big network with qualified personals, right? You just imagine how much opportunity you are getting, right?
Yeah,
If I was a student, right, I still say to everyone, I would have definitely joined this course and I would have participated like anything, like with full josh and, you know, with full info and everything.
Actually, that was the reason for joining me. Actually, that was the main reason. Means they said that you need a degree, and I just enrolled here.
So you see, you have all that advantage, but what you should really focus on is building your skills, right? It's your
Basically,
skills matters.
learning the basic concepts. If you learn the basics, then it will be much more helpful. Because, for example, just for qualifier, for graphing, if we can graph the question in 1 minute, then the answer is done, just done. So the basic is very important.
Right.
Sir,
So that's what, like, yeah, Rahul, go ahead.
Sir, I have a question regarding these bonus marks, sir. Sir, it is written that we get bonus marks if we submit practice assignments. But practice assignments, some of the assignments get solutions after a few days, sir, before even the deadline passes. So how does that work? We have to
What does
submit.
it matters is like you have to participate in give I mean, what does it matters here is you are actually saying that practice assignment and you are giving answers. That is
Okay, even after the solution is posted.
Yeah.
Okay.
So we can give any time.
Yeah.
Deadline is 30 March times.
23rd March.
If we won't qualify now, can we continue this course and attempt
Yes, you
again?
can continue. Yeah, you can do that.
We
So you
have to do
started.
all this week 5 to week 7. We will continue.
Continue. Keep on doing.
4
Then,
subjects. No, if you won't qualify, not qualify case.
Still you continue. You will have access to this.
And
maybe then your marks will
next
not be evaluated later on. Or you'll like...
The syllabus for qualifier, sir?
Sorry?
Which will held in March.
Sorry, what?
What will be the syllabus for the next qualifier if we won't pass? No?
4th week.
1 to 4.
1 to 4, yeah.
So, and what?
But again, we need to start right term. After the results came, again we need to start the term from week 1.
You have to basically write quiz 1.
Okay, if I won't qualify, March 13, I will write one more quiz. And if I get qualify in March 13, then how my term will start?
Next term.
Yeah.
Next term.
Yeah.
So entire
this won't
week
continue?
1 to 12.
No, but you will get an extra chance of your qualifier, right? So that will be the thing.
So when it is?
It won't continue. It won't continue.
I
from
guess it
now
won't
onwards.
continue. I'm not sure of this. I guess it won't continue.
Okay.
Yeah.
Okay.
So then what will be the syllabus for quiz 2 that will happen on 13th
Quiz
March?
2, yeah. So that thing will be like your week 5 to week 9.
Someone was saying
1 to 9, only 5
Week
to 9,
5
right?
to 9 or 1 to
More
9?
emphasis to week
9.
5 to 9.
Okay.
9. For maths, it is 9. For others, I guess it is 8.
Sir,
1 to 9 or 5 to
1
9?
to 8.
Basically 1 to 9 because there can be some kind of intermixing, but you can
Okay.
give more emphasis to 5 to 9.
Okay.
It's worth reading from the beginning because in your end term, all your weeks will have an equal weightage.
Okay.
So it's worth reading.
So we will be getting.
I had realized it last final term when stats was mainly on the recent weeks and maths was, I mean, I did not give maths, but I got to see the maths paper and I saw it had questions from week 1 to 4 also.
We will do the same again.
Yeah, even in this qualifier also, most of the questions were from week 4 only because the initial weeks were very early, I mean, very basic level concepts.
So you see, like basically you will have some kind of intermixing, but you would have seen like not much intermixing has been happened this time.
No, not.
Yes.
It was easier. It was much easier. In fact, we thought this was an experiment. We were just experimenting it. And let's see how is the result.
There was a server outage due to which means question was not loading for me. That's why I had to complete the last in 45 minutes and left the last 3 questions. Means
Get it.
partially done, not completely. It was not. I was not able to complete the whole.
This losing time happened everywhere. I think internet connections, disconnections, and this
I don't
problems.
get why it is happening. Means
No, losing time is all right, but whatever we had done, that was also erased. Fortunately, that outage happened at the very beginning. If it had happened somewhere in the middle, then then it would have been disaster.
No, it was
Which
for
location
me
was
from
this?
Hyderabad.
CT to mathematics time. Means CT to mathematics. When I was jumping from CT to mathematics or statistics to mathematics, it was happening.
So
So again, you went back and again you kept all the answers.
Yeah, I was jumping. Means if I found that one of the question was means hard, then I just for just a sake of change of my mind. Means suppose if you have given any answer which is very easy, then you can just your mind just changes. So that was my thought, and I was just jumping like that. For English, I completed in I think in mostly 30 to 35 minutes. Yeah.
No. He's telling its data is erased. Submitted answers is erased.
It happened at the very beginning. Like we had a connection for 10 minutes and then it got disconnected for 20 minutes. So fortunately, I started with English, so it was not a big problem. So then I started English from the beginning, and then I went on. I was saying, what I was saying was, if the outage happened, suppose after 1.5 hours,
yes,
then it
it's
would have
really
been a big
difficult.
problem.
Or towards the end of the exam.
Just a minute. So I just wanted to confirm, like it was just in Hyderabad or like everywhere?
Sir, here also means in Gorakhpur also I faced the same. Maybe for my piece system only, or I don't.
Here in UAE,
I don't know if there was a
exam in
power cut.
UAE. Here also
for
this
power cut there
server
was
connection
there,
disconnection happened.
Okay.
I don't know if there was a
Disconnections happened.
disconnection or not, but when I was giving English exam, the audio was appearing and disappearing. So I had to go through other questions to see if I'm
True. Happened for me also.
Yeah.
So that happened to everyone, yes. Even for me.
Yes,
If the
video
audio
clips
was for
happened.
2 questions, the audio did not appear for the first question.
Same. Means it was lagging a lot. Lot of lag was there, I guess.
Yes, lag was
while
also there.
moving
The
from
question,
one question to
most
the
time
one
was
I
question to
remember
the
there was a
second
question which says at 54 seconds, but that word came at 59 seconds.
Yes,
Yeah,
exactly.
it was like that. Means I had to rewind and then hear. Means every time.
One first video clip, 6 minutes video clip. For me it took 10 minutes because while going from first question to the second question, again it restarted for me.
Same happened to me.
For
Means
4
basically I had
questions,
to
for
hear
4
each
or 5
time.
questions, every time it restarted. So for 6 minutes audio clip, I played for 10 minutes.
Yeah, okay, I understood. Means basically that was happening for me also. Means the audio was not loading. Means I thought that my earphone is.
It was also disappearing from question to question.
Yeah.
That's
I
what
don't
it's
know what was
restarting.
happening, but this
All
was.
right.
So I have a question. Last time, because of time constraint, we couldn't discuss it. The zoo one, can I have it better framed to check if the approach is correct?
I can we do this in the next session, because I just have a meeting.
So it's
now.
very difficult for me to join. I won't take more than a minute. So
like okay. So yeah, tell me, go ahead.
so
But I have
what
a meeting right
couldn't,
now.
I won't take more than a minute. I promise, sir. So I couldn't explain in words that time, but what I did was Royal Bengal tigers and male tigers was given. The union of was given. So basically, it was the formula: Royal Bengal union the males is equal to Royal Bengal plus males plus the intersection. So I got the intersection and I subtracted it from the number of males, and then subtracted the number of males from the white tigers, and I got the female white tigers.
I also did the same.
Means
So that is the right approach, right?
Right only. I also got
only.
it.
Even I also did the same.
Actually, what you are telling is like it's basically the same thing only, right? It's
Yeah,
Yes, but that was a longer this.
Yeah, it's the same thing.
I couldn't explain it that well.
Yes,
the
yes,
other
I
day.
also did it. I also did later on with Venn diagrams. True. What you did
Yeah,
is
that's right. That's perfectly fine.
So that day I couldn't explain it properly, and you said you will have to check it once. So that's why I just wanted to.
Yeah, that
my
is fine.
confusion
So I'm
arrived
done in a
because
minute.
of that wording. That wordings, my confusion arrived for that question. But later I found that this means Royal Bengal female and Royal Bengal male are together. So means I solved it very easily after that. Means the wording was They play with
Anyways,
words.
all right. So I'll
Okay.
just
Thank
end
you,
the
sir.
session. Yeah, thank you.
Yeah, thank you, sir.
Thank you so
Thank
much.
you.
Thank you, sir.
Thank
Yeah.
you.